Hi and welcome to CareOps course, building an end-to-end healthcare operational analytics pipeline. So in this quick video, I just wanted to set the learners' expectations real quick. So let me expand this. So you should have prior knowledge of Microsoft Fabric, and this course is an advanced course. So this is designed for learners with hands-on experience in, let's say, ETL, where you're very much familiar with extracting the data, do the required transformations, and then loading the data. And you should have some experience with creating reports and dashboards in Power BI. And with respect to the programming languages, you should have a very good hold of SQL and Spark fundamentals you should be familiar with, because throughout this course we have many PySpark notebooks that we have built to flow through the data across the medallion architecture. So if you're new to medallion architecture as well, we will talk more about it during the architecture overview. So you should also have a good hold of PySpark, as I mentioned. So you should understand the Spark fundamentals and then the PySpark programming knowledge, which is must to kickstart this course. And in case if you're a complete beginner to this course, so I would recommend you to watch my free Fabric end-to-end course with the COVID-19 dataset, which is available in the platform. So I would recommend you to first watch the free course to understand the foundational concepts of Fabric and then the fundamentals. And then once you have a good hold and the familiarity of the Fabric components, then you can move on to advanced courses like this. So that's my recommendation, and you should gain some familiarity with, as I mentioned, Fabric components and the fundamentals, like what are Fabric workspaces capacity, what is OneLake, and what is data warehouse if you're not aware, or what is the difference between Lakehouse and warehouse and stuff like that. And also, if to gain some hands-on experience, you need to activate the Fabric trial. So in the free course, I have also directed you to some YouTube videos to activate your Fabric trial, because you cannot activate your Fabric trial with your personal email address. You should have a business email address. So we have a workaround to activate the Fabric trial, because the goal of these courses that I'm building is to help you with hands-on experience. So if you're completely watching the videos, and then if you're not having any hands-on, then there is no use of application itself. So the whole idea of the course is to apply whatever you are learning throughout the course. So you should make sure to activate the Fabric trial and then get some hands-on into it. That's the vision that we have in DataBN Academy. So I hope you will enjoy this course. And I think I just wanted to set the expectations right before we even kickstart the course structure and the architecture overview. So I will see you in the next one. Thank you. Hi and welcome back. So we are in module 1, and in this video we'll quickly go through the course problem statement, and then we will quickly look at why we are going for Fabric SQL DB, which is in preview. And we'll also quickly look at the code structure, the list of modules, and what we are going to cover in each and every module throughout this course. So let me open the problem statement. So we are actually looking at a healthcare POC. So in today's world, healthcare organizations face critical challenges in managing patient flow and resource allocation, right? So we can look at the patient flow and admissions. Hospitals are struggling to manage those. Tracking admissions, discharges, and readmissions accurately is essential for their patient care, right? So optimizing the patient care. And however, there are many inconsistencies they face and data silos that often lead to inefficient workflows for hospitals and healthcare organizations, and delays in treatment as well. But that's exactly we are trying to address in this POC, to help the healthcare organization to efficiently manage their patient flow and then the admission and discharge management, right? So we'll see how we can help healthcare organization in this POC to manage their patient flow efficiently. So that's one that we're trying to address. And then the bed occupancy optimization. So what we're going to address is hospitals are struggling to manage or look at the bed occupancy rates, right? So we are going to efficiently see how we can manage bed assignments, and then monitoring occupancy rates are key to reducing their patient wait times, right? And ensuring that resources are available when needed, right? So, and it is actually linked to the admissions and discharge. So it is a bit complicated, but I will try to explain in a way. When we go through the modules, we will see how we can how we are addressing those challenges to make sure it is efficiently managed for healthcare organizations. And then the resource allocation and utilization, right? So hospitals must they must dynamically allocate resources, such as, let's say, equipment, hospital ward equipment, staffs, and then the beds, to meet varying patient demands, right? So, and it is really challenging for them to allocate those resources. So we are going to see how we can solve that challenge and help them to efficiently allocate the resources. So poor resource planning can result in underutilized or even overburdened assets, right? So we are trying to find that sweet spot to help the hospital or healthcare organizations to efficiently plan or allocate the resources. And then the data quality and historical tracking. So that's very important, because it is very crucial to capture and preserve the full history of patients, right? So we are going to implement SCD type 2 for patient dimension in this course, and it will be very interesting to see how we are going to implement that, because we are going to preserve the history for patients for operational purposes. So we'll see how we are going to implement that. And this allows for both deep dive analysis in case we have generated some reports for patient deep dive analysis. You know, if in the reporting, if you want to drill down to patient level, because the fact table that we are going to create is at the patient grain, okay? So that in the reporting, we can drill down to the patient level to look at individual patients and their admission patterns, and then readmission patterns, and so on and so forth. So that is very crucial for, let's say, deep dive analysis per patient and aggregated reporting to inform strategic decision making, right? So that's exactly the goal that we're trying to achieve here. So that's the high level problem statement, you know, that we have taken for this course. We can see all these challenges are almost available in every healthcare organization, and how we can help utilizing Fabric components and then the Fabric SQL DB for operational analytics end to end. So we will, in the next video, we will go through the high level architecture that I've built, so that you will get a good idea how we can build those components end to end. And primarily we are leveraging Fabric SQL DB for operational analytics. So we will quickly see why we need it is in preview. We'll see why we need Fabric SQL DB for this use case for operational analytics, right? So let me close this. Why we use SQL database in Fabric? So there are advantages, you know, we will quickly go through it. So it is still in preview, and we are leveraging, as I mentioned, SQL database in Fabric for several reasons. So when you're creating SQL database in Fabric, you know, you will essentially have three items created in the Fabric workspace, you know, when you create that. So which is your actual SQL database, and then the data in your SQL database will automatically be replicated to the OneLake, and it's converted into Parquet format in the analytics ready format, which is great, because, you know, you will also have the SQL analytics endpoint once you create the SQL database, and it enables you to perform all the downstream scenarios for let's say data engineering, data science, and so on and so forth, right? So, and default semantic model will also be created. But as I mentioned, I think the great news is, I think yeah, it keeps up to date in the queryable format in OneLake. Okay, so all your SQL database data, it will be automatically replicated, so you can use all the different services in Fabric, you know, so such as running analytical workloads in Spark, executing in notebooks, and data engineering, visualizing through Power BI reports. So you can use almost any analytical engine in Fabric. It can talk to OneLake the replicated data, and it's ready for your further analytical workloads. So that's a great advantage that Microsoft implemented, because now once you create your SQL database and then start building the tables, it will be automatically replicated to OneLake and it's ready for further analytical processes. Okay, so that's one point I wanted to highlight, since we are leveraging SQL database in Fabric, which is still in preview at the time of recording. Okay, so as I also mentioned, it creates 3 items. The SQL Analytics endpoint. So for our data model in the later point of course, when we create the data model, we actually leveraged SQL Analytics endpoint that is created with the SQL database, and then we built some views on top of our tables, and then the views are actually used to build the data model. So we will talk more about it when we move on later on in the course, right? So that's, I wanted to quickly, I'll also share this link as I mentioned in the lesson below, so that you can read more about SQL database preview edition in Fabric. Coming back to the course structure, so we talked a bit about the problem statement, that we're going to build the solution for that problem statement, and then a bit of overview on why we are going for Fabric SQL DB, leveraging it in Fabric, and then we will quickly look at the course structure now. So the journey is split into kind of 7 or 8 modules, okay, as you can see here. So that we are in module 1, we are looking at the introduction. So also I will cover the CareOps architecture, building an end-to-end healthcare operational analytics pipeline shortly in the next video. And then we have module 2, where we are exploring the synthetic data generation library, okay, because we cannot do this POC with the real data, right? So with respect to healthcare domain at least, right? So we have leveraged Faker Python library, okay, so we'll talk more about it in that module, how you can actually simulate the patient data or whatever healthcare data that you need using this library to generate the data synthetically, right? So that we have leveraged synthetic data generation using the Faker Python library for all the requirements for this POC, like for patient table and then admission discharge, let's say, and then resource allocation, bed occupancy. So we will talk more about it, how we are generating those synthetic data for our use case here, right? So that's on module 2. And then the module 3, we will build the bronze layer and medallion architecture. So basically we are looking at medallion architecture, as most of you are already aware. We will flow the data through bronze, silver, and then our final gold fact table, right? So in the module 3, we will primarily focus on how we are going to build the bronze layer tables in the medallion architecture for all the required dimensions, and then the staging data that we require for further downstream process, right? And then in the module 4, as I mentioned, we are going to perform some transformations in the silver layer, and then also as a part of the silver layer, we will implement the SED type 2 dimension for patient to preserve the historical patient records, which is very critical for our reporting as well. But when we take it to the data model, we will take the latest snapshot of the patient, and then we have also implemented the surrogate key. Okay, so we will talk more about it when we implement the SED type 2 dimension for patient dimension, okay, in the module 4. And then in the module 5, we will actually build the gold layer, which is our fact table, okay, the patient fact that I talked about. It is at the patient grain that you can do your reporting once the data model is built. And then in the module 6, we will talk in detail about data movement, because in the next video during the high level architecture, I will show you, we will basically build all the required tables in the Lakehouse initially, and then we will seamlessly move the data to the SQL DB, okay? So that we will handle as a part of module 6, how we can seamlessly move the data between Lakehouse to the SQL DB. And then we will create some views in our SQL Analytics endpoint in SQL DB, and then we will build the data model out of it. Our semantic modeling will be top of the views. And there are some warnings, we will talk about it in case if you're building your semantic model on top of the views. So what are the challenges, right? So that Microsoft is warning you. That we will also cover, and that's a good opportunity for us to leverage building the data model on top of views and how we can address those in case if we need it. That's an opportunity for further performance fine-tuning, I would say. And then in the module 7, we will do the dashboarding and advanced reporting. So we have several reports that we will build. As I mentioned, at the patient level grain, we will build some reports, and then looking at the admission discharge trends, and then resource utilization rates, and then the bed occupancy rate, and so on and so forth. So there's a lot we can do reporting on once we have the semantic model ready in module 6. And then we will build some couple of dashboards, one the summary dashboard, and then we can also have some patient level grain dashboard, as I mentioned. So if you need to drill through every patient and look at the admission patterns or discharge patterns, readmission gap and readmission patterns, and so on and so forth. And then in the module 8, we will wrap things up, and probably you can bring in your points for real world discussion and then Q&A to see how we can improve this CareOps POC further and fine-tune the entire solution, I would say. So that's how we are structuring this course, split it into 7 modules actually, and then the 8th module is for further discussions. So I hope you will enjoy this course throughout, and welcome again to kickstart this journey. Thank you. Hi and welcome back. So in this video, we will quickly look at the architecture for CareOps POC. So we will, this is at a very high level. So we'll quickly run through what are all the components involved for this architecture end to end to build the reporting for this CareOps POC. Okay, so here you can see the architecture. So our data source layer, as I mentioned in the previous video, we are going to leverage Faker Python library for synthetic data generation. That is going to be our data engine, I can call it. Okay, so for whatever tables that you require for your needs, we are going to generate all those in bronze layer with the help of Faker library. Okay, so we will look into that in the next module when we kickstart the bronze layer loading, right? And I think we are, as I mentioned, we are going to follow this architectural pattern, which is medallion architecture. So we are going to build all the required tables, the raw tables in the bronze layer, right? And then we transform the data and clean the data and then load it into our silver layer. And the SCD type 2 dimension loads for patient dimension happens in silver layer. Okay, and then all these we will perform in PySpark notebooks. Okay, and I hope if you're not familiar with Spark fundamentals or PySpark, please go through the fundamentals and get some idea how the processing is happening behind, right? So how it assigns the work to different nodes in the cluster and how the work gets done and then brought back to the driver. So those basic fundamentals you should be aware if you're probably new to the Spark world. So get some hold of Spark because we are completely going to do some hands-on in the PySpark notebooks. Okay, and then we will have our goal layer at the bottom that you can see. And as I mentioned, there are some tables that we're looking at, which is the patient info, which is going to be SCD type 2. And then, as I mentioned, the patient's admission discharge. So all these tables are kind of interlinked. As you can see, when you build the admission and discharge tables, you would need the patient keys, right? So which we build in the patient dimension. So it is going to be purely driven by the patient key. Okay, the admission and discharge for the patients, and then the bed allocation again should be interlinked with these two tables, because it cannot be outside of the ranges for any patient, right? So it should be within that range, the admission discharge range, the bed allocation for any patient, and that could be multiple admission for any patient, and we need to also handle that scenario as well, right? So those are all taken care. We will talk in detail. It is quite complex probably when we move on further on through the modules, we will talk about how we have handled those complexities and how we have addressed those as well. And then the resource utilization table again that we have built. So these are some critical tables that we have built in bronze layer. We are going to build in the bronze layer, and we'll run through those notebooks and then how we have transformed into silver layer. And then finally our fact is going to be the fact patient admissions, which all these transform tables would be loaded in the Lakehouse. Okay, as I mentioned, we are primarily going to create our bronze and silver tables in Lakehouse. Okay, and then we'll also build or load the fact table by joining with different dimensions into the Lakehouse. So once we have all the required tables which are ready to be moved to the Fabric SQL DB, we will run those pipelines to seamlessly move the data from Lakehouse to Fabric SQL DB, okay, which is in the preview. And we have also leveraged OneLake shortcuts for a few dimensions. If you have already leveraged, let's say, the reusable dimensions, you can call, right, like dim date, dim location. So I think we are not using location dimension for this POC, but date dimension is something we require. So if you have already used or created such dimension in any other workspace for any other POC, which we already have for COVID project, so I'm utilizing shortcut to bring in that dimension and then plugged it in so that I can reuse the same dimension without creating again, right, for this POC. So we have leveraged OneLake shortcuts for that to bring in the dimensions that are required from other solution, okay, from other sources as well. That's our goal layer. We are going to seamlessly move the data between Lakehouse to the Fabric SQL DB, and then I'll have the required dimensions and fact table, which is at the patient grain, as I mentioned. That granularity will be loading into the Fabric SQL DB, and we will be building the Fabric semantic data model on top of the SQL Analytics endpoint that will be automatically created, as I mentioned in the previous video. When you're creating SQL DB, all your data will be automatically replicated to OneLake, and your SQL Analytics endpoint would be ready for further downstream process. So we are utilizing those views that we are creating in SQL Analytics endpoint, and then we are building our semantic data model on top of the fact and dimensional views. Okay. And once our data model is ready, then we are ready to go. We are going to build our reports and dashboards in Power BI right within the Fabric platform itself without moving on anywhere. So that's how we are going to build it. But this is at a very high level. How are we going to build right from the data ingestion and then flowing the data through different layers in medallion architecture, right from bronze, silver and gold layer, and then how are we going to seamlessly move the data from Lakehouse to Fabric SQL DB, and then building those views. And we have a lot of SQL queries to validate our data, because as I said, it is going to be very complex, and we need to make sure we are validating data at every level to make sure the data is valid. And as I mentioned, it is interlinked, and we need to make sure we have those validation queries in place to validate the data that is loaded. Okay, and since we are looking at synthetic data, there are chances of data quality issues, so we need to address all of those since as we are not looking at the real data set. Even in real data set, you will have many challenges, but we are trying to mimic or simulate with the Faker Python library, and we have all those SQL queries, validation queries, that we're validating whatever is required to make sure we have a kind of working POC to bring it to our portfolio. Okay, so that we can be confident in handling such scenarios or such POCs for customers going forward. So let me know in the comments in this lesson what do you think, if there are opportunities to fine-tune this architecture further. So this is at a very high level, so we will move on with the course, and in the second module we will talk about how we can leverage the Faker Python library to build our bronze layer, right? So thank you for watching. I'll see you in the next one. Hi and welcome back. So we are in module 2, synthetic data generation with Faker, right? So in this module, we will quickly look at the Python library Faker, which we can use to achieve or build the data sets that we require for our simulation for this healthcare POC. So we'll quickly look at that library and how we can import that library and generate the data sets, right? So that's all what we are going to look at in this module. So let me quickly show you the Faker Python library. So I'll share you the link in this particular lesson. You can find the link below in this lesson. So all you need to do is you need to do the pip install Faker in the notebook. That's it, and then you can start generating the fake data according to your needs. Okay, so it's all about generating the fake data when you need to bootstrap your databases. And in our healthcare POC, we wanted to build the data sets for patient and admission, discharge, and then the bed allocation, and then resource allocation. So there are quite a few data sets that we need to generate using this Faker library. Okay, so we'll see how we can achieve this in the next video. So I'll see you in the next one. Thank you. Hi and welcome back. So in this video, we will quickly look at creation of the data sets, as I mentioned in the previous video, the patient info, admission, discharge, bed allocation, resource allocation. So we will quickly look at the notebooks, how we are using the Faker library. We are building that cookup data, but we will revisit those notebooks again in module 3 when we are building the bronze layer and medallion architecture. But as a part of this module, we will quickly look at those notebooks and how we have leveraged Faker library, and then we are building the data sets that we require using Faker library. So let me move on to Fabric portal. So here I'm inside the Fabric portal. So you can see I'm inside the workspace healthcare operational analytics. Okay, so you can also look at this in list view by clicking the list view that you can see here. All the artifacts that I've built for the solution you can see here. Or if you want to look at lineage view, you can click on the lineage view on the right side. That will also show you the complete lineage view, which is which will also help to look at the flow, right? But I think for now I'm switching back to list view, and you can see I've created quite a lot of folders. Maybe we can quickly look at this structure or hierarchy inside this workspace, and then we can look at the bronze notebooks where we are building the data sets using Faker library. Okay, so here you can see I have admission, discharge scripts, bed allocation scripts, then the CareOps Lakehouse, and then the SQL DB and data pipelines. I put it in a separate folder, then data flows, dimensions, fact loading, and then the patient dimension ACD type 2 scripts. And we have the dashboards, couple of dashboards, then our semantic data model, then reports, and resource allocation script separately, right? So those are the artifacts that we have here in this workspace. Okay, and I think a few pointers. You may want to enable the source control for your workspace, which you can do it by configuring the workspace, Git workspace, Git integration under the workspace. You know, when you click on workspace settings, you can see all of those settings here. And under Git integration, you need to link your Git. So if you haven't done that, you can explore that. And in the free Fabric course in my platform, you can watch. There is a separate video that I've covered in detail how we can set up the Git to control the source that you're creating in this workspace. Okay, and you can also look at the other information in the workspace settings, but for now let me close this. And you can also manage the access to this workspace. Okay, and the deployment pipelines as well when you want to navigate from test your pre-production environment to your production environment. That as well I have covered in the free Fabric course, how you can create those deployment pipelines for your workspace, okay, for your solution. So apart from that, let me open this admission discharge scripts. Okay, or we can probably look at the patient bronze script first. So I think in the next module, when we look at the notebook in detail for every data set that we are going to build, so I'll share the notebooks in each lesson so that you can follow along through the course. So for now, there are quite a lot of notebooks in this patient SED type 2 scripts folder, but let me open the bronze initial load script. Okay. Okay, so here we have linked the CareOps Lakehouse. Okay, so that we will come to that part in module 3, but for now, let's have a look at this installation script. So which is exclamation pip install faker is all you need to install the faker Python library in this particular environment. And you need to make sure you're having the PySpark, because there are quite a lot of other APIs that you have, Scala, SQL, and also T-SQL and Python. But we are going to completely work through the solution using PySpark notebooks. It's a lot of notebooks that we'll walk through to make sure you understand what we're trying to do and building the solution, okay, from scratch. So in the environment, you can see it's a default runtime, which with the Spark 3.5 and Delta 3.2. And you can change the environment if you want, but it is the default environment that we have, okay, with the compute that is dynamically allocated, and the number of executors are 1 to 9. Okay, so when you have, I think regarding the trial activation and all, I hope you by this point you already have the trial account, since this is an advanced course. If not, you need to go back to the free Fabric course and then try to activate the trial with your business email address. There is a workaround for that. You can do that and then make sure you follow along through the course. So then it'll make sense to get some good hands-on throughout the solution. Okay. So once you do the pip installation, then you'll have the faker ready. Okay, it will be installed and it will be available for you. And all you need is, so I'm not going to go through in detail every line of this code. We will do that. We'll revisit this notebook during module 3 when we talk more about building the bronze layer and medallion architecture and loading the data into the Lakehouse. Okay, but for now, just a few pointers related to faker I just wanted to show you in this notebook. So don't worry much about the rest of the scripts. So from faker, we are trying to import the faker, and then we are instantiating the faker library. Okay, then assigning it to fake variable, right? And I think if I scroll down, I think when we are building the schema for the patient, let's say patient dataset, right? So this is my schema. So I'm defining the schema, as you can see here. I need the patient ID, patient name, patient age, gender, marital status of the patient, diagnosis, last visit date, and then the ingestion timestamp. This is my schema for the patient dataset. And I think, how are we going to leverage faker library in this case? So the patient ID, I'm just going to call this unique ID4 function from faker library. So that will help to generate the unique ID for whatever set of records that you wanted to generate. In our case, we are going to generate, let's say, 100,000 records, okay, by iterating through the for loop and then generate it. So it will uniquely assign the ID, okay, the random unique UID function will take care of it to assign the patient ID with the help of faker library. So that's exactly I wanted to randomly generate the unique patient IDs. And then the name also, you can call the fake that we have instantiated here and call the name function. It will generate random names for you, okay, for those 100,000 records or even 1,000,000 of records. You can call that function, and it scales significantly. Okay, so you no need to worry about it. Just for the purpose of POC, you can even test with 10,000 records or 100,000 records. That's more than enough, and it's tested. So you can call the name function. It will assign some random names to the patient name. Okay, so that's exactly what we needed here. And the age also, we are calling random function here and randint function to assign the age between a specific range between 18 to 90, let's say, okay, or you can tweak that as well, okay. And the gender, again, we are calling the faker library instance, and we are calling random element function, and we are passing predefined set of values. That is also possible, if you want. I think for 100,000 records you cannot pass the random, a specific predefined set of names, right? So that's not feasible or doesn't make any sense. But I think for gender, it is going to be a predefined set of values that you know already. So you can call random element, and then you can pass the elements. So it will randomly assign those gender to all those 100,000 records, okay. And marital status, again, you can pass the predefined set of values in the elements array to the random element function in fake. It will take care of it. Diagnosis, again, we are passing predefined set of values like cardiology, orthopedics, neurology, oncology, general, and you can pass any set of values here. Feel free to change it. You don't want to mimic exactly what I'm doing here. You can kind of explore further how we can leverage this, right? And last visit date, again, we are passing the date between function in the fake instance, and I'm saying the start date should be -2y, which is the last 2 years, and then today. So it will generate the date between now and then the last 2 years. In between those range, it will try to create some random dates for the last visit date as well, okay. And then the ingestion timestamp, we are passing the load date, which is which we'll look into it later, okay, when we go through line by line the code during bronze load building. But at least for this session, I hope you have a bit of idea about faker library and how are we utilizing the inbuilt functions in faker library, Python library, to generate those random data for us for our use case, for the patient ID, name, age, for this particular schema for the patient, okay. And maybe let me show you one other notebook for the faker library in action. Maybe we can look at admission discharge bronze script. So here I'm again installing. So for every notebook, you need to install the faker library so that you can utilize, probably in that particular instance or Spark session, you can utilize and then call the required functions to achieve what you want. So again, we are instantiating and calling it as fake, and don't go through this notebook probably at this point in time. It is quite complex. We will go through in the third module quickly, line by line, to make you understand what we are trying to do here. But I think you can I think what we're trying to do here is in admission and discharge, we need to align, we need to reference the patient IDs, which is already there in the patient dimension, right? So that's exactly we are trying to do here by still we are calling the random element, but we are passing the patient IDs from the patient dimension, okay? But we will come to that. So I think that is also possible, in the elements you can pass the predefined set of values, or you can build that array and then pass it to the element. So you can see here it is a list already which we built, okay, in the earlier code, and then we are passing it, but we'll come to that, okay. And yeah, I think it's quite a lot, but I just wanted to show you probably at the end. Here you can see we are creating that admission record for a patient, the admission ID. Again, I'm using the UUID4 function to randomly assign those IDs, and patient ID cannot be randomly assigned because, as I mentioned, it should be referencing the patient itself, right, for any admission. So that we have done that. And what key, you can see, I think we are calling random element, and then the ward patient ward keys, we are passing predefined values, and then admission date discharge cannot be randomized. So we have some logic in place. We will go through how we are deriving the admission discharge date for that patient, and then diagnosis, okay, also a predefined set of values. So here the faker only for admission ID and then the ward key, we are using the faker library. Otherwise, we have some logic in place to derive the patient IDs and admission date, discharge date, and diagnosis that we will go through in the next module. Okay, so but I think for all those, even for bed allocation and then the resource allocation scripts, we have imported the Faker library in a similar fashion, and then we have utilized the Faker library to randomize the attributes, required attributes that we have randomized. So I think that's a lot for this session. So, but I hope you have got the point. The idea of using Faker library to build the data set for my use case here for healthcare POC. So I'll see you in the next one, wherein we will quickly look at the best practices to simulate, let's say, when we are using this Faker library and generating the synthetic data for healthcare kind of POC, how you can kind of follow the best practices to kind of simulate the, let's say, the COVID kind of trend, right? So how you can do that. So that we can quickly look at, and then probably we'll jump on to the next module and then walk through the notebooks, every notebooks, and then try to understand what we are trying to do and how we are implementing the logic and all. We'll go through that and start building the bronze layer in the next module. So I'll see you in the next one. Thank you. Hi and welcome back. So we are in module 3, building the bronze layer in medallion architecture. So we will start with ingesting the raw synthetic data into delta tables in Lakehouse for all the required dimensions, let's say for patient, for admission, discharge, bed allocation for patients, and then resource allocation as well. So those are the tables that we are looking at. We will quickly run through the PySpark notebooks, line by line code, so that you will get to understand what we are trying to do and what are the different rules that we are applying. In case of admissions for a patient, there could be multiple admission for a patient, right? So how are we handling the overlaps? What are the logics that we have implemented to make sure we are handling those overlap and all. So we will quickly look at that, and then we will see how are we ingesting the tables, bronze tables, into the Lakehouse. And then we can talk about best practices to simulate the seasonal trends, let's say, to simulate the outbreak spikes like COVID kind of scenario. And then as a part of third video in this module, we will run through some of the SQL validation queries to make sure there are no overlaps, as I mentioned, and then looking at the date consistency and then the distribution as well, the data distribution across the months. So we have some logic implemented with monthly caps to kind of simulate that distribution every month. So we will talk about that in detail in this module. So let me move on to Fabric portal real quickly. So here I'm in Fabric portal inside the healthcare operational analytics workspace. So before we jump on to the notebooks, so let me move on to the document just to quickly give you some pointers, as I mentioned. So for the bronze layer ingestion, we are going to load the raw delta tables, the synthetic data, into the Lakehouse, partitioned by diagnosis, okay, for the patient and admission, discharge. So we will be partitioning the data by diagnosis, and that is a predefined a set of values that we are going to ingest, okay, that we will look into it in the notebook. And then the admission, discharge, there are a few things to keep in mind. As I mentioned, we implemented a logic to track each patient's last discharge date to ensure their new admissions always happen after the prior discharge date, right? So that is a validation we need to make sure. Since we are working on a synthetic data, we need to implement this and handle this rule so that there will be no overlap in admissions for a patient, right? Otherwise you'll mess up the data, right? So since we're working on a synthetic data, so that is one thing we are taking care to make sure we are tracking each patient's last discharge date, and then we are synthetically generating the new admissions based on that, right? So we will look into that. And then we are also marking the active patients with the no discharge date to prevent simultaneous open admissions for the patients, right? So if they are already active, and we cannot generate one more record for the patient, synthetically, and that will collapse the data again. So those are thumb rules, you can say, to mimic the real world hospital kind of a scenario, but I'm just trying to asking you to keep this in mind, so that when we go through the notebook, we are already taking care of these in the notebook, okay, with respect to admission and discharge for the patients. And I think for the bed and resource allocation, so we are making sure to generate the bed assignment records and resource events within each patient's valid admission window. That is very critical, right? So you have to generate the synthetic data for bed assignments for any patient within the admission window, right? So it cannot be outside of the range. That will again mess up the data. It is not a real world scenario we are looking at. So to mimic the real world scenario, we are making sure we are also generating the bed assignment records to fall within the patient's admission window. So when we look at the code, yeah, it's a bit complex to handle all these scenarios. Since we are generating synthetic data, we cannot rely on the real world healthcare data. So we need to make sure we are handling all this to mimic the real world scenario, I would say. So just keep this in mind for now. So when we go through the notebooks, you'll get a good idea on how are we implementing these rules, you can say, right? So let me move on to Fabric portal again. So we'll first probably look at the patient dimension, right? So let me open this folder, patient. So here we have the bronze initial load, silver, and then the incremental SED type 2 load, and then the surrogate key update. We will talk more about it when we implement SED type 2 in the module where we are transforming the data, right? So but for now, for this module, we will look at how are we ingesting the bronze layer data for the patients. So let me open this notebook quickly. So you will find the notebooks under each lesson. So for the bronze load in this module, you will find all of the bronze load related notebooks attached to this lesson, so you can download and follow along through the course as well. Okay, so at this point, if you haven't created any Lakehouse, right, so make sure you create a Lakehouse. So within the workspace, you can go and create a new item and then create the go to all items and then create the Lakehouse. Just search for it. Okay, and then just create the Lakehouse. You can name it, let's say, CareOps Lakehouse, the one that I've named. Okay, so and then make sure you map the Lakehouse to this particular notebook. So that's the first step you need to do. And if you haven't added anything, if you're not seeing any sources, you need to add the existing sources, right? And then link the CareOps Lakehouse, because at the end of this notebook, we'll be storing the bronze table in the Lakehouse, not directly into the SQL DB, as I mentioned in the architecture diagram. So we are going to seamlessly move the data from Lakehouse to SQL DB with the help of data flows and all. Okay, so once you are done linking the Lakehouse, created and then linked it. Okay, so just minimize this for better view. So let us go through the notebook real quickly. So I think we are first step would be to install the faker. So we already talked about in the previous videos how you can leverage the Python faker library, so that you can install. And I think the required libraries that you need to import: the PySpark SQL for the import the Spark session. Then under SQL types, you are importing struct type, struct field, string type, integer type, and date type to build the schema as such. Okay, and then from PySpark SQL functions, you are importing current date, and then faker, we are already importing faker instance. Okay, and then the random library as well. Okay, and let me move on. So we are just trying to initialize the Spark session as well as the faker. So for every block of code, I've commented with the understandable comments, you can say, so it is easy for you to understand as well. Okay, so here we are trying to define the bronze schema for the patient. So it is going to be the patient ID, name, gender, marital status, diagnosis, and then the patient last visit date, and then the ingestion timestamp. And then we are defining the data types for each and every attribute with the struct field function, and then the types that we have imported. Okay, and define the bronze schema, and we are going to generate, let's say, 100,000 patient records for the bronze table, and you can tweak and then play around with that, but for the demonstration purposes, I'm going to create 100,000 records. I'm just keeping it in a variable, and then I'm going to use the yesterday's date as the ingestion timestamp. Okay, just for the simulation purposes, the load date you can call Spark SQL function, and then we are calling the date sub function, okay, and passing the current date as load date, and then we are trying to collect it, okay, with the collect function, and first in the array as the load date. Okay, so that's how I think we have already imported the current date here, so you can utilize that function, and this line of code will fetch the date, the yesterday's date. See, I think here we are trying to make it as yesterday's date as the ingestion timestamp, so we'll come to that, but for now I think we are using this date sub function to not pick the current date, actually the yesterday's date as the load date, okay, and then we are trying to collect and then store it in the load date. And then the data bronze, we are creating a list, okay, and then empty list and keep it, and then we are trying to iterate to the range function the number of records, which is 100,000 records, and I'm going to iterate and then create those synthetic 100,000 records for me by using the Faker library, right? So for some of the attributes like patient ID, I need the unique ID for 100,000 records, so I'm using this UUID function. And for fake name also, I'm just trying to generate randomly the names. The library will take care for me. Age, we are using the random function, and we wanted to restrict it. We cannot probably use a Faker library and randomly generate the age, right? So we need it to be in a defined range. So that's why we are giving it between 18 to 90, let's say. Okay, you can tweak that as well. And I think gender, marital status, diagnosis, we are passing the random elements, right, the predefined random elements to the records, so it will assign anyone. Okay, so but I think you don't want to worry too much about it, because the name could be something like Felix or some men name, and then if you see the gender is assigned female, I think that's totally okay. Just for the POC purposes, we cannot be 100% controlling the random assumption of values to those records, but that's totally okay. Just for the demonstration purposes and POC, we're just trying to create the synthetic data. But if you want to have more control, like the name should be aligning with the gender and so on and so forth, you need to probably put more controls to the code, right? So but it's already complex, the code is already complex, so let's not worry too much about it. So it could be a female name, but the gender could be assigned as male, but that's totally okay. It will be randomly assigning. And then marital status, diagnosis, you can still expand the diagnosis list. And then the last visit date between today and the last 2 years, okay, we are passing the date between function, and then we are using the Faker library again. And then the ingestion timestamp, we are using the load date, which is the yesterday's date. At the time of running, it will be loading the yesterday's date. Okay, and that is a reason for it. I'll come to that. Okay, or you can also keep it as today's date. It makes sense. Because at the time of running, I had to run this multiple times, and I had some challenges. So that's why I was tweaking the code to make the load date as yesterday's date. But that's totally okay. You can keep it as current date. Okay, that's totally fine. You no need to keep it as yesterday's date. And then the data bronze, the empty list, we are appending the record. So that's how we are keep on appending the 100,000 records. And then once the loop is done, you'll have the 100,000 patient records with all the randomized values stored in this data frame. You have to create the data frame because this is list. So you're creating a data frame out of the list, and you're passing the schema that we have defined here, right? So what should be the types as well. Okay, and then you will have the data frame, bronze data frame ready, and all we need to do is we are going to write it to the delta table, right? So I'm naming it as patient info underscore bronze, and then I'm writing the data frame in delta format. The mode is overwrite, and I'm going to partition it by diagnosis, okay, as I mentioned, and I'm saving the table, okay, saving test table with the name, the bronze table, which is the patient info bronze. and we are just printing the final statement. The initial load is completed with 100,000 records. So the last executed, you can see it is inserted. So you can run this block of code and validate the patient info bronze table, okay, and see if you can see a kind of realistic data for the patient. So maybe let me move on to the Lakehouse. We should see all the tables there. We'll go through it one by one. So here I have many tables for this POC, but let us look at the patient info bronze. But I think, yeah, so here you are trying to look at it within the notebook. So maybe let me move on to the Lakehouse itself. If I just come out, CareOps Lakehouse, it's trying to open the Lakehouse here. And there you go, you have loaded the Lakehouse, and under DBO schema, under tables, you should see all the tables loaded now. But at this point in time, once you load the patient info bronze, you can have a preview of the table. Okay, so let it load. Usually, yeah. Okay, so now you can see the data preview. The patient ID, name, age, gender, marital status, diagnosis, last visit date, and ingestion timestamp. So that's exactly we wanted, and it is during the silver transformation, we'll be converting this dimension into a SED type 2 dimension, and we'll see how we are implementing that. But for now, for the bronze raw data, we have generated randomized data using Faker library for the patient info bronze layer table. Okay, let us quickly go through the admission discharge bronze script. So this script is quite complex, I would say, but we will we'll get there. Okay, so we'll go through block by block and try and understand what we are doing with this script. Okay, so don't worry, I'll take you through each block of code quickly so that you get to understand what we are trying to achieve in this notebook. How are we handling those rules, as I mentioned, to avoid any patient admission overlaps and all. So as usual, just make sure you install the Faker library within this session using pip install, otherwise it won't be available, you might be getting error. So then import the required libraries, the PySpark SQL session, and then the types, and random, and then datetime, and then initialize those. And here we have a custom function defined, which is random date with seasonality, that is taking in start date, end date, and month weights. See, the whole idea of using this random date with seasonality function is to introduce seasonality in the data, to mimic the seasonality in the data. For example, I think here I have the month weights, a list that you can see, or a dictionary, as you can see, for every month. What is the weight? Like, you can see for I'm trying to mimic kind of the winter seasonal flu kind of scenario. To mimic that, I've given the weights for December and January as 1.5. Okay, so for higher weights for those 2 months to mimic the seasonal flu, right? So to mimic that kind of scenario, or you can tweak this to any scenario that you think, and then play around. But the whole idea of this custom function is to generate those random dates with the seasonality. Okay, so if I give 1.5 and 1.5 for December and January, when the data is generated, when the random dates are generated within this range, start and end date with the month weights passed, you will see the dates are assigned to those months based on the weights what we have defined here, and that's exactly what we are trying to do here. Okay, and you can go through the code, like we are getting the days list, okay, with the start and end date parameter that we are passing, and the date weights, okay, we are trying to get here, and then we are trying to randomly generate the date from that dates list, because we need to randomly generate by applying the seasonality within this range, start and end date range. So we are getting the days list, and then we are getting the weights accordingly, date weights, with the get function from this month weights dictionary, and then we are randomly assigning by applying that seasonality for that particular weighted months, right? So we'll see this in action when we call this function, but for now, just keep in mind we are having this custom function random date with seasonality that takes in the start and end date and then the month weights dictionary, okay, that we can pass it to that function, okay. And then we have a monthly cap dictionary for the last, let's say, 6-7 months, starting from October, and I'm just again trying to have a higher cap for December and January, and for rest of the months it's going to be 1,333, because you may have a question, why this number? Because I'm just trying to consolidate it to a kind of 10,000 records, not more than that, so or approximately 10,000 records for the last 6 months period. So you can play around with these monthly caps again, and it's not necessarily you need to follow this, but just for demonstration purposes, I'm building this dictionary to mimic, let's say, a seasonal flow kind of scenario, and we'll also kind of mimic the COVID outbreak kind of scenario. I'll show you that as well. How are we mimicking that as well? But moving along, now the critical part is for the admission and discharge bronze table, you need to read the existing patient IDs and diagnosis from the patient info bronze that we generated in the previous video, right? Or in the same video just before this notebook we have just created. So that is critical because you need to reference the patient and then the diagnosis. So that is something you need to do. So we are just going to use the Spark read table function, and we are collecting or selecting those two attributes, patient ID and diagnosis, and with the collect function I'm going to get the patient data and store it, okay, in a variable, and then I'm building the patient dictionary. As you can see here, it's kind of the dictionary will be like patient ID and then their diagnosis for every row in the patient data, okay, and then the patient IDs, I'll build a list using the keys, because the key will be the patient ID and then the value will be the diagnosis. That's how I'm building the patient dictionary, okay. And then you're storing the patient IDs list by calling the patient dic.keys. So that will store all the let's say 100,000 records, patient records that we have ingested, that will be stored in the patient ID. So I'm just as a initial step, we need to store the existing patient IDs and diagnosis from the patient info bronze table, and I'm defining some dictionaries for my tracking purposes in this notebook. So what are those tracking activities that we're doing here? So we need these tracking structures to avoid any overlap and to enforce the monthly caps, as I mentioned, right? So we have the last discharge date dictionary that tracks the last discharge date for every patient, and the last record that tracks last generated admission date, discharge date per patient. And the active patients, it's a set, we have patients with active open admissions, and the monthly counts. So the key is like year and month, and the value is going to be the count of admissions, okay. So that's how we are going to build these dictionaries for tracking purposes. And some of the simulation parameters, the target records, we are not looking at 1 million or 100,000. We are just going to keep it simple with 10,000 records, and then we are defining the ward keys. In the hospital there could be different wards, and we are going to define, let's say, imagine we are going to have 4 different wards, so A, B, C and D. So we have predefined set there. And error probability, for now I'm keeping it as 0, but this you can probably play around to inject some error records in your table, but for now I'm not giving any error probability. I'm keeping it as 0, and then we have today's date as well, and we have a list, empty list data, and then attempts variable which is set to 0, because we're just going to iterate through those 10,000 records. We are going to run through that using the while loop. And I think if you're trying to generate massive records, maybe we need to optimize the script. I'm not sure, maybe you may run into performance issues if you're using while loop for let's say 100,000 records or even 1 million records, but you need to test it in case if you're playing around, and in case if you're facing any challenges, there are opportunities to fine-tune the script always. But for now, for demonstration purposes, I think we can move ahead, okay. So We are using this while function, while loop, length of data less than target records, which is going to be 10,000 records. That's it. And we are kind of iterating these attempts. Okay. Okay. Now what we are going to do is we are going to randomly select the patient and get diagnosis information for that patient. Okay, using the Faker library. In a random element function, you can pass the elements, the patient IDs that we already built here. Okay, so that will randomly, from 100,000 records, it will randomly pick some patients and then store it. Okay, so we are going to iterate through every patient and then generate some synthetic admission records for those patients. That's it. Okay, and what we're trying to do here is we are trying to skip through the loop if this patient already has an active open admission. So we as I mentioned, we have this dictionary set. Okay, so to track the active patients, and I think during the start of the loop nothing will be there, so it will go ahead, and in case if we have if that patient ID is already active, then we are not going to generate the admission record. It will create duplicates, right? So we are when we say continue, it will come out of the loop. Now also we are trying to skip if the last record for this patient is today, to avoid any duplicates as well. So if the patient ID in last record, and the last record is today's date, then we are skipping out of it. Okay, so if the last record for this patient is today, to avoid any duplicates. And here we are trying to determine the valid minimum admission date. If the patient has, see, the rule here is if the patient's previous discharge has already a previous discharge, then the new admission record that we are going to create is 1 day after that. As simple as that. Okay, so if the patient ID is in last discharge dictionary, so I think we have the dictionary for that as well. As I mentioned, we are tracking it. If the patient ID is in last discharge dictionary and the last discharge dictionary patient ID is not none, we have some checks. Then the minimum admission date, min admission date, is the last discharge date dictionary, the patient ID, plus date time delta is 1. So we are just incrementing 1 day after their previous discharge. So as simple as that. And in case if the minimum admission date is greater than today's date, we are keeping it as today's date. Cannot be future date, right? So we need to, since we are generating this data synthetically, we need to put those checks as well to make sure the data is clean, I would say. So otherwise, if the patient is not there in the last discharge dictionary, then I think for the very first admission record for the patient, so we can narrow the range to the last 6 months using the seasonal weighting. Now comes the custom function in action. Okay, so that we discussed in the earlier part of this code. So we are just going to generate passing the start data 6 months ago and then today's date with month weights that we have already defined. So this custom function will randomly generate the dates between these ranges by applying the month weights that we have defined to mimic the seasonality, kind of a seasonal flu kind of a scenario, right? So that will be the minimum admission date for the new admission record for the patient. So as we discussed here, so it will be this custom function will mimic that seasonality based on the weights that we have defined here. So that's the idea. And then in this block of code, we are trying to generate the admission date between the minimum admission date and today using seasonal weighting again. Okay, so we have the minimum admission date. Okay, if the patient already got discharged, we are incrementing it by 1. Otherwise, we are randomly generating the admission record with the seasonality using the custom function, right? So now, if the minimum admission date, we are having some checks. If it is greater than today's date, future date, then we are keeping it as today's date. And then we are again calling the custom function and then passing the minimum admission dates and today's date between this range. Using the month weights, I need the admission date for the patient. As simple as that. And then we're handling the exception as well. And then in this block of code, what we're trying to do is we are trying to enforce the monthly cap. Check the admissions for the month of the generated admission date. So what we're trying to do here is The monthly cap, as I mentioned, for every month, when we generate this admission record, it shouldn't be breaching that monthly cap. Okay, so I'm just trying to keep a check for every month to make sure the data is evenly distributed, just for our POC purposes. So that's exactly what we're trying to do here. The admission year, from admission date, I'm extracting year and month, and then the current month count, we are keeping a check. The monthly counts dot get. Okay, so monthly counts dot get the admission year and month. So the monthly counts, we have already defined it, right? So you can see it's a empty dictionary. The key would be the year and month, and value is the count of admissions, right? So that's how we are defining it. So when we pass the admission year and month, you will get the counts, the current month count. So we are keeping a track of it in this dictionary. And then the cap, how are we getting the monthly cap dictionary? We are passing the admission month, and then the target records. Okay, so divided by 6, that will get me the cap for that month. Okay, so once you get the cap stored here, so we are then checking if it has, a particular month has reached that cap. If it reached that cap, then we are just skipping it, right? So, and then otherwise we are just adding it to the dictionary, monthly counts dictionary, for that particular year and month. We are incrementing the count. So that's exactly what we are doing here. Let's move on. So here, now we have the admission date minimum. Now the admission date generated with the help of that range between minimum admission date and today's date, and calling that custom function. So we have the admission date for that patient ID. Now we need to generate the discharge date with a 70% chance, because you can still tweak this. I'm just giving a number there. Kind of chance of getting true is 70. I'm using faker library boolean to simulate, and also to simulate the length of the stay between the 1 to 14 days. You know, it cannot be like 2 months, 3 months for a particular patient. So we wanted to simulate the length of the stay between a realistic length of stay for a patient, right? So it could be even a month, but we will try to kind of mimic the real world situation, right? So we are having this random variable length of stay by passing the random int 1 to 14, and then the proposed discharge will be like the admission date, and then we are calling the time delta and date time function, and then we are passing the days as the length of the stay. Okay, so that will, the proposed discharge variable will have like admission date, and the kind of the length of the stay is between 1 to 14 days. Okay, so that will be the proposed discharge here. And instead of forcing to today, if the proposed discharge is after today, we will keep it as active. Okay, so that's exactly what we are doing here. If the proposed discharge is, we cannot be future date, so we are keeping it as none, so which means the patient is active. And then else the discharge date is the proposed discharge date. Okay, so we're just trying to mimic based on that length of the stay variable, we are trying to propose that discharge date. Okay, otherwise if the 70% chance, for the 30%, you know, they'll be like active patients, you know, they're not discharged yet. So that's what we are trying to mimic for those 30% of the patients. Okay, using this function. And what we're trying to do here is we are trying to update active patient tracking and last discharge date. We have some dictionaries, we need to make sure we update that. So we are adding the active patient, the current patient that we are working through in this loop. We're adding it to the active patient dictionary so that we can keep a track and make sure the next time we are not duplicating the records, or if the patient is already active, we are not adding another admission record for that patient. Okay, as simple as that. And otherwise, you know, the last discharge date for that patient, if the patient is not active, we are building this last discharge dictionary for that patient by passing the discharge date. That's it. Okay, and we are keeping some extra checks. If both admission and discharge dates equal today and record already exists, then we are skipping it. So if the both admission discharge date equals today, and that's a kind of validation checks we are doing, and the record already exists, then skip it. So if the admission date and the discharge date is today's date, if it happens on the same day, which is today's date, then we are skipping it. Okay, if the patient ID is in the last record and the last record patient ID is today's date, then we are skipping out of it. Okay, so that's an extra check that we are doing to make sure we are skipping out of it. We are not generating any patient record for that patient. And moving along, record the current admission for this patient. So again, the last record for that patient, so we are building that with the admission date and discharge date. So that particular dictionary will hold the admission date and discharge date for that patient ID. Okay, the last record dictionary that tracks the last generated admission date and discharge date per patient. Okay, so that also we are trying to build. And now we are coming to the actual record creation part, the admission record creation. We are building that dictionary, record dictionary. Admission ID is going to be a fake ID, and then the patient ID, we need to pass that patient ID that we already keeping a track from the patient table, so the one which we are working through for that patient. What key we are passing with the predefined set of values, and then the admission date and discharge date that we have already derived with logic that we have just gone through. We're going to pass that, and then the diagnosis is going to be the patient diagnosis itself from the patient table. And then data.append and records of the data, that the empty list that we have keeps appending that record, and then finally it will after so many attempts, I think we are trying to generate 10,000 records, the target records, so it will be generated with this logic in place. And then we are trying to define the schema for the admission record. It is going to be admission ID, patient ID, what key, admission date, discharge date, and then the diagnosis for the patient. Okay, and it referenced the actual the patient ID in the patient info bronze table. Okay, and we are keeping a track of the admission, discharge, and then the logic as we mentioned. For that could be multiple admissions now at the end of the script, so we can validate that as well. So you may see more than one admission happen for a particular patient, but it shouldn't be overlapping, and that's exactly what we were trying to implement the logic to make sure we are keeping a track of the last discharge for a patient. We will always generate the record probably the next day after their discharge date, something like that. So I hope it makes sense and clear to you. If you have any questions regarding this implementation, feel free to comment in the lesson below. Okay, or you can write to the email itself, academy email. I'll be happy to help you through that. Okay, and finally, once we have the data list, right, so it is ready, the data dictionary is ready that we have defined here. It is the list that we are converting into a data frame and passing the schema, and then your data frame is ready, and then you're going to store it as admission, discharge, bronze table as delta table, partition by diagnosis again. So all the tables we are going to partition it by diagnosis. That's our strategy here. And finally we generated those 10,000 records after so many attempts. Okay, but you can run the script and see how it works for you. And maybe we can have a quick look at the table that got generated in the Lakehouse. So it is already generated. I'm not running the script again, so it is already executed and loaded for you. You can follow along and execute the script and generate the table. In case of any challenges, feel free to reach out to me. So the table is generated. So we will probably in the next video, we will run some validation queries to make sure there are no overlaps, as I mentioned, in the admission records, and whether it is within the range. When we run the bid allocation script, so we need to make sure it is falling well within the admission date ranges. So that kind of validation we need to run some SQL queries and validate against, that we will go through. But you can look at the preview of the data that we have just synthetically generated for admission, discharge for patients. We can just eyeball through it. Here you can see the admission ID and the patient ID references the patient ID in the patient info bronze table that we have generated just before this script, and what key, predefined set of values, and then the admission date and discharge date. You can see it's generated accordingly, and we also made sure the discharge date. Yeah, so for any particular patient, if you have multiple admissions, it shouldn't be overlapping. So those validations will it's better to run some SQL queries and validate. Okay, so you can see the admission discharge date is loaded, and then the diagnosis information as well. And since we partition the data by diagnosis, you can always check how the data is partitioned, right? So if, let me open the Lakehouse, the Explorer, I come back to, so let me say for the admission discharge bronze, go to properties. Okay, so there you can see the URL and relative URL and all, but I wanted to look at the files. Let me see how I can get to that. So I'm in SQL Analytics endpoint. Let me move on to Lakehouse. So when you get to Lakehouse, you can see a triangle icon, which means like all these tables are delta tables loaded in Lakehouse. Right click the three dots, click on View Files. There you can see the admission discharge bronze is partitioned by diagnosis. You can see a separate folder created for every diagnosis for cardiology, general, neurology, oncology, and orthopedics. And if you open that, you can see a Parquet file, right, loaded there for every diagnosis. So we can clearly see the data is partitioned by diagnosis. At the time of storing, we asked the engine to generate this table partition by diagnosis. Okay, so that's about admission and discharge bronze. It's a complex script, so I hope you got a good understanding of it. In case of any questions, feel free to reach out in the lesson below with the comments. I'll be able to respond. And let us move on. We'll also quickly look at the bid allocation script, and then the with respect to the bronze layer and also the resource allocation as well. So let me open the bid allocation script real quick. So let me open the bid allocation notebook. So here again, you need to make sure you are linking the Lakehouse for us to be able to write to the delta table once we are done with the processing or synthetically generating the data using Faker. So here in bid allocation, again, I'm installing Faker and importing the required libraries and then initiating the sessions. This is not very extensive, but we will quickly run through the bid allocation script as well. Okay, let's look at the resource allocation PySpark script and see how are we going to generate the records, the synthetic records using Faker library. Regarding bid allocation, so we will look at the bid allocation script during our silver transformation layer in the next module. I'll tell you the reason why, because we need to rely or extract the data out of the admission discharge silver table, not from the bronze table. The reason is in the admission and discharge silver table, you'll have reliable admission periods for any patient, right? So we cannot rely on bronze table to extract the admission period for any patient, and you may have some inconsistent data there, right? So that's how it's linked from bid allocation to the admission discharge silver table. So I think we need to transform the admission discharge bronze to the silver table, and then we will look at that silver table and rely on the admission periods for any patient, and then we generate the synthetic data for the bid allocation records for any patient. So I hope it makes sense. If you have any questions around that, you can write your questions in the lesson below using the comments box, and I will be happy to assist you further. So we will go through the resource allocation script, and then we talk more about the bid allocation logic during our silver transformation layer. So that's one thing to keep in mind. So let us move on regarding the resource allocation script. As usual, you need to install the Faker library, and you are importing the PySpark SQL libraries session, then required type struct field, string type and date type, then importing the Faker library, and then importing random and then instantiating, right? So as usual, well, I think it's duplicated. Maybe you want to delete this cell. Okay, so it is already captured within this notebook, so here it is kind of duplicated. You can remove that. Here we are initializing this POC session. You can give the name of your choice, resource allocation load or whatever it may be, and then instantiating the Spark session and the Faker library. And what we're trying to do here is, again, we are trying to read the existing patient IDs from patient info table, okay, for the resource allocation. So here I think we are looking at the patient info bronze. It is totally okay. So we are going to generate some synthetic records for the resource allocation. And we are trying to select only the patient ID from the bronze table and storing it in patient data frame. And patient IDs, we are trying to extract the patient ID row by row from the data frame, and we are collecting and storing the patient IDs here. Okay. And we are defining the empty list as data, and then the number of records you can play around. If you want it to be 10,000, just keep it. Here I'm giving 100,000 records. And what keys, we are having a predefined list for 4 wards. Resource types, you have a predefined list: equipment, bed, staff. Resource status options, it could be either assigned, the bed or staff or equipment, or it is available. So today date we are assigning, and then moving forward we're trying to iterate and then trying to generate the records. And resource ID, as usual, we are going to call the UUID4 function to randomly generate unique ID for the resource ID. And resource type, we are passing the predefined list to the random element function. What key, again predefined. Patient ID cannot be randomized, it should be from the existing patient info table. Okay, and then we are generating the assignment start date, which is from the last 2 years. So using the date between function in Faker library, we are assigning the start date. And I think here what we're trying to do here is with 50% chance, you can play around. I think whether you want it to be 50 or 70% chances. We are generating a valid assignment end date, that is after assignment start date, right? So, and here we are using fake boolean, and then chance of getting true is 50, and we need the lower bound for the assignment end, which is the assignment start date plus 1. So the logic is plus 1 with the assignment start date, and if the lower bound is greater than today's date, we are going to default it to today's date. Else the assignment end date, we are going to generate between the lower bound, okay, which is start date plus 1, and then today's date. Between those ranges, we are going to generate the assignment end date. Okay, any date between those 2 ranges. Otherwise we are going to keep it as today's date. Okay, so otherwise in the else part, we are keeping the assignment end date as none, which means the resource is still active, or resource is still assigned. It is not available for further allocation, you can say. So resource status is we are randomizing the resource status. Either it could be available or assigned. Okay, but I think it shouldn't be the case, but here I'm randomizing it. Maybe it's a homework for you. So tell me, how are we going to how you can approach this challenge or problem, right? So ideally, I don't want the resource status to be randomized between the resource status options like assigned or available. Instead, I wanted to look at the assignment end date, obviously, right? If it is if there is no end date, then yeah, it is actually still assigned. If it is ended, then it is available. So I think it's a basic logic, we need to apply by looking at the assignment end date and then assign the resource status as whether it is available for further allocation or not available, right? Assigned. But that's a simple change. You may tweak the code and modify the code and run it. Let me know the results, right? So then you can start loading the synthetic data. So and the resource status would be reliable. Now I think with the script what I have, it would be randomized, even with some assignment end date, you may see the resource status as let's say it's available, right? So it is active. So similarly, when the assignment end date is none, ideally it should be still assigned, right? So but you may see the resource status as available. So that, I think probably with this kind of code, it may not be reliable. You can look at the assignment end date and then tweak the status accordingly. So just modify the code accordingly and let me know. That's a homework for you probably, but that's fine. Let's move on. Then we are trying to have a record variable and then resource ID, whatever we built. So all those variables we are passing in for the resource ID type, what key. This is our schema: patient ID, assignment start date, end date, and resource status. And then we are trying to append the record and iterating through that, right? And we are defining the schema, and then we are creating the data frame by passing the schema, and then we are trying to write it as a delta table, partitioning by what key this time for the resource allocation. Okay, so we are going to look at the resource allocation for every ward and saving the table as resource allocation. Okay, and we are not going to have it as bronze and silver. We are going to tag it as resource allocation table and then keep it same for bed allocation. Okay, but if you think the script can still be improved, and then the synthetic data, as I mentioned, we can still fine tune the script. Please feel free to do that and provide your comments how you can further optimize the script to generate that reliable synthetic data for our POC. Okay, so I'm just printing it. So at the end of the script, yeah, we are just saying the delta table is created successfully and partitioned by what key. So let us quickly look at the table that got generated. If I go back to the workspace and open the Lakehouse, CareOps Lakehouse, click on the Lakehouse, and let us look at the resource allocation table that's loaded, delta table. And you can always see the files. You can view the files and see if it is correctly partitioned by wards, as you can see here across 4 wards. And let us look at the sample data quickly. So resource ID, resource type, whatever predefined set of values that if given, and what key, patient ID referenced, and assignment start date, end date, and resource status. So here you can see there is a assignment end date, which means like it is correctly providing it. Still it's randomized, as I mentioned. It is saying available, which is good. It is already ended, so it is available. The resources, the staff is available, whatever resource it may be. And I think you can still fine tune the script to make this resource status even more reliable. And if you see some assignment end date, but looking at this, we have end dates for all, probably the 50% chance that we have given, right? So I think you can still fine tune the script and have the synthetic data loaded in resource allocation. Well, that's about resource allocation. I think probably we are coming to an end of this particular video. So probably in the next video, we will look at various SQL scripts to validate our bronze tables that we have generated, like the patient info bronze, the admission discharge bronze. As I mentioned, we need to run some queries to validate if there is no overlap with the patient admissions, and so on and so forth. And also the resource allocation, we can run some scripts to validate the data as well, right? So in the next video, we will run some validation scripts, SQL scripts, and make sure our data is reliable for further downstream processes like the silver transformation. So I'll see you in the next one. Thank you. Hi and welcome back. So in this video, we are in module 3. We'll look at validating the data quality with SQL queries, especially the admission discharge bronze table that we have loaded with a lot of logic in place to avoid any admission overlaps. And then we look at the consistent data and then distribution as well. We have set up some monthly cap, and we also need to see the distribution per month, how the admission records are generated for patients. Let me move on to Fabric. So here I'm in Fabric workspace. Okay, so let me open the Lakehouse, because we are going to run through some queries, SQL queries, and SQL Analytics endpoint. I'll show you exactly how are we going to do that. So let me open the CareOps Lakehouse. There you're inside the Lakehouse. And I think all I wanted to do is I wanted to run some scripts and validate my data which is available in the Lakehouse. So on the right top, you can see we are in Lakehouse, and you can switch to SQL Analytics endpoint to query the data using SQL, right? Let me switch and move on to the endpoint. And now you can see your schemas are loaded, and you can see there is a separate section, queries, wherein you can start writing some queries on top of your tables to validate your data. So if I expand my queries, I have quite a lot of queries that I have written to validate the data that we have just loaded, and we also have some scripts to validate the silver layer data. Let's not worry about it at this point in time. We'll look into that later, but let me move on to this admission discharge bronze checks script. Okay, we minimize this so that we'll have a better view. So there are some scripts here, so we'll quickly walk through this to see what we are trying to validate here. Okay, so I'm going to check the count of records where the discharge date is before the admission date. So that's the first check you need to do once you have loaded the bronze table for admission discharge for patients. Since we are generating the synthetic data, as I mentioned, we have to be extremely careful to validate the data to make sure there is no inconsistent data, otherwise it will mess up your report, right? So what I'm going to do is I'm just going to validate my admission discharge bronze table that we have loaded in Lakehouse, and all that I'm saying is I need to pull the count of records, where I'm saying I think the function here is some case when the discharge date is I'm having a case condition here when the discharge date is not null, and when the discharge date is, let's say it's less than the admission date, then 1, else 0. So we have a case condition and we are aliasing it as inconsistent records. Okay, so we're trying to sum up after the case condition the number of records that we are going to get. Okay, so so this will give you the total number of records in this table, and this will probably provide you the count of inconsistent records. Okay, so when the discharge date is before the admission date, then that is an invalid record that we have generated. So discharge date should always be greater than the admission date. So you cannot have a discharge date before the admission date. That will mess up your report. So let me run the script quickly and see what we get. So the total records is 10,000 records that we have generated for admission discharge table, and then there are no inconsistent records. So we can clearly see the data is reliable. We are not seeing any records where we have the discharge date which is less than the admission date. Okay, so it should be always greater than the admission date. So, and let us look at the duplicate checks. So here we are we are grouping it by patient ID, admission and discharge, and then we are checking if there are any duplicate records in the table, okay, using having count of staff greater than 1, and then we are ordering it by duplicate count. Let me check that real quickly, and there are no duplicate records as such. So the script worked really perfect to generate the synthetic data. And yeah, I think you can look at some distinct of admission IDs if you want. Let me move on. So here, in case if you're probably looking at some inconsistent records, then you may want to have a look at those inconsistent records, right? So you can run this query to look at those records where the discharge date is not null and if it's less than the admission date. So you may have a look in case if you're seeing some inconsistent data there, right? But right now we are looking good. So let's move forward. And here what I'm trying to do, so I'm looking at the count of admissions in the bronze table, grouping it by patient ID. So what I'm trying to do here is we're grouping it by patient ID to see if the script generated some admission records, I mean the multiple admission records for any patient. So we can see if there are multiple admissions for any patient and whether the data is available to simulate that scenario. So if I run the script, I think you should see, I think for patient IDs, many patient IDs, there are a couple of admission counts, which means the patient got admitted more than once. And I think this is the first check that you need to do before you do the overlap check. If a patient have more than one admission records, since we are generating the synthetic data here, you need to make sure the records, the admission records for any particular patient shouldn't be overlapping. Okay, so that we will check next. Okay, so this is the query. Let me just expand it for you to have a better view. So this is the query that we are going to run to check the overlapping admissions for any patient. So how are we going to do that? I'm going to do a self join here, admission discharge join with the same table. We are doing basically a self join on patient ID. Okay, and then here we are pulling the patient ID, then first admission date, first discharge date from first instance, and then second admission date, second discharge date. Okay, we are aliasing it to make it easy to understand. And then we have an AND condition where admission date, A dot admission date is less than B dot admission date. What we are doing here, we're trying to compare distinct records. Okay, so here that's the condition we are making, where A dot admission date is less than B dot admission date, which means we are comparing distinct records for any particular patient. Okay, so that is to compare the distinct records, and what we are doing here in the where clause, and this is the overlap condition that we have here, right? So what is this overlap condition? Where A dot discharge date is greater than B dot admission date. So look at that again. A dot discharge date is greater than B dot admission date. Okay, so that will tell us it is a overlap, right? So it shouldn't be overlapping. The first admission and discharge shouldn't be overlapping with the second admission for the same patient, right? So basically checking if for that patient, if the first discharge, whether it is greater than the second admission. That's it. That will tell us if there is any overlap for any patient admission within our data set. So that's the check that you need to do, and if this script is returning any records, then you have a problem. You have some overlaps, and that cannot happen in a real world setting. The patient got admitted and discharged, and then they'll get readmitted, okay, only after the discharge, right? So it doesn't make sense if you're looking at a discharge date which is greater than the second admission date, and if that's the case even in a real world setting, then there is some problem with the data, probably the data quality issues, you can say. But we need to make sure, since we are generating the synthetic data for admission records, we have to be very careful to make sure there is no overlap occurring for any patient, as we are simulating more than one admission, multiple admission for any patient, right? And it is a valid scenario, right? So we have to be extra careful and validate the data that we're generating. And we are saying the discharge date, B dot discharge date, is not null. So we are just trying to consider only the discharged admissions, okay, only the completed admissions. So let me run this from here, run the script, again, let me just scroll, select only this block code. Yeah, let me run this. It's taking a bit of time usually. Yeah, okay. We have the results. So there is no records returned here in the result set, which means our data is clean, I would say. So there is no overlap for any patient in our data set. So the even for a patient with multiple admissions, the data is clean, looking clean. So that's the kind of check that you need to do to make sure. And I think the SQL Analytics endpoint comes really handy to execute such queries and validate your data in the Lakehouse. Okay, so let's move on. Let's do few more checks, the null checks in the admission ID or patient ID or admission date. So whether we have any null problems, null records, no, we are good. And finally, we will run this query to look at the distribution for every month. If you remember in the script, so we set the monthly cap for every month, just for the sake of distribution across months, probably 6 months, right? So last 6 months. So we have that monthly cap logic to define the distribution. So let us see. So I'm just using the datepot function on top of the admission date, and I'm extracting the year from admission date as admission year. Then using the datepot function, I'm extracting the month out of admission date as admission month. And then I'm looking at the count as admission count. And we are grouping it by using the datepot function. We are grouping it by year and month, and then we are ordering it by year and month. So on top of the admission dates in admission discharge bronze table. So this will tell us how your data is distributed across the months. So let us quickly look at this, run the script and look at the data, admission discharge bronze table. And there you go. So I think right from 2024 October, we gave it as like last 6 months, when we generated the data synthetically, and we have like 668 admissions in October. And then if you remember, we wanted it to be like 10,000 records, right? So, and it's equally distributing with, if you remember, we had month weights, right, for December and January. For those months we gave higher weights, if you remember, right? So you can see it produced 2000 admissions for December and January to simulate flu kind of scenario, right? So we simulated that, and we can see it's generated 2000 records, admission records, for those 2 months. Otherwise it sticks to the monthly cap, what we set, like 1333 admissions for other months until April. Okay, so looks good. The distribution is also looking good. So that's the kind of set of queries that you need to run to validate your data, especially when you're generating synthetic data using Faker library. So I will share the script in the lesson below so that you can follow along and then run these queries and make sure the data that you loaded in bronze table, especially the admission and discharge table, is reliable. So in the next video, I think we will move on to module 4. Let me quickly move on. We're done with module 3, I would say, and in the next video we will look into the transformations in the silver layer, and that's going to be a bit complex because we're going to look at the SED type 2 patient dimension, and then, as I mentioned, we will also generate the bed allocation records on top of the admission discharge bronze, because we need to refine, I think, I think we need to do some feature engineering to generate that admission discharge silver. Otherwise the data is quite clean in bronze table already, so we are already handling the overlapping, and we will look at the readmission logic, and I think seasonal adjustments are already done. So we will see what we are going to do with respect to the transformation for admission discharge into silver, then SED type 2 implementation for patient dimension, okay, and then kind of validating the bed allocation. Even bed allocation needs to be generated, validating it, and also validating the silver tables through some SQL queries as well. So I'll see you in the next one. Thank you. Hi and welcome back. So we are in module 4, transformations in the silver layer, and in this video we will look at cleansing and enriching the raw data from bronze layer, especially the admission and discharge bronze. So if you remember, I think we have the admission discharge bronze, and we have performed validations against overlaps, admission overlaps, and a few other queries we ran to check the distributions and all. But in this video we will see how we can transform and enrich the bronze layer with a few additional columns as well that we require, and then take it to the silver layer for admission discharge. And then I think in the next video, if you remember, once we have the silver layer ready for admission discharge, then we need to work on bed allocation, data ingestion. So as we spoke in the last video, so we will work on that bed allocation ingestion, and then we'll purely focus on implementing SED type 2 for the patient dimension. Okay, so we have the patient info bronze table by now, and in the third video in this module we will look at how do we create those silver table, wherein we look at the SED type 2 for patient dimension, right? And also the surrogate key, how are we going to implement the surrogate key, because later on when we build the data model, we are going to pull the latest snapshot for the patient. Okay, so once we implement SED type 2, so when I say latest snapshot, we're going to pull the current records for any patient, right? That we may probably preserve the history in the backend. Okay, so that's why we are implementing it as a SED type 2 table for patient dimension. That would be the SED type 2 table would be our patient info silver. Okay, so we'll purely focus on that implementation, and with the surrogate key implementation we'll talk a bit about why we are implementing surrogate key, because I think once the historical records or the data is loaded into the fact layer, So I think later on, whenever there is an update to the patient, right, so we will preserve the history and then amend the record in the SCD type to table. And we always need to make sure all the historical data that we surface to the cube and in the reporting should still reference the latest snapshot of the patient. So that's why we need to make sure we implement surrogate key for patient to make sure, I think, all the historical data or historical admissions for any patient should always reflect the latest position or latest snapshot for that particular patient. So I think that will be a detailed demonstration, I would say, and we have quite a few scripts to cover, so we will talk about it and look at how we implement it in detail. So that's going to be very critical for this POC. So we'll learn how you can implement ACD type 2 dimension using PySpark notebooks, and we're going to simulate the updates and inserts. Okay, so and then see how it works as well. And finally, in the last video, we will look at how we can validate with, as usual, we'll have some SQL queries, and we run through the SQL queries to check if the bid allocation data that we ingested is okay, and whether it falls within the range, the time range, right? So for any patient admission, right? So it should fall within the admission range for any patient. So that's what we need to make sure the synthetic data is valid and reliable. And we'll also create quite a few dimensions like dimension ward and date. I think, as I mentioned, we can use we can reuse the dim date from other workspace or other POC using OneLake shortcuts. So if you're hearing OneLake shortcuts for the very first time, I think, we will briefly cover it, or else in my free Fabric course I have covered in detail what is shortcut, and maybe you can see that OneLake shortcuts in your action. So it's simply we are referencing the dimension from other workspace or other solution, okay, and from different sources as well. You can bring the reusable objects, okay, using OneLake shortcuts. So that's all we are going to look at in this module. So we will kickstart looking at it one by one. So let me move on to Fabric portal. So here I'm in the workspace healthcare operational analytics. So before we get into the admission discharge silver script, okay, so I wanted to show you a few data pipelines that we are also going to build. Okay, so you probably when you want to probably run it in one single orchestration, so you need to have the data pipeline, master pipeline built. So I can quickly show you the master pipeline, and then we can jump on to the script. So once you are done with all the notebook development, you can club it together or chain it together in the master pipeline. So for admission discharge pipeline, you'll have two scripts attached to it, one admission discharge bronze that we have already built, and the one which you're going to look at now in this video. So you can create a simple pipeline, and you can run this pipeline to make sure, I think, both the bronze and silver layer loads correctly. Okay, so that you need to make sure. So you can create a simple pipeline like this, and you can use different activities like notebook, and you can use copy data activity, or you can invoke a pipeline, other pipeline as well. And if we look at the master pipeline, I think we'll revisit this master pipeline, but I wanted to show you. So here you can see the first activity in the master pipeline for CareOps should be the patient pipeline. Okay, so for patient we have a separate pipeline, patient dimension pipeline. So we will talk in detail about it in this module. It's going to be a bronze initial load, silver initial load, and then the incremental load, and then SK update. So there are 4 scripts. I think the bronze initial load we have already covered. So the patient info bronze loaded successfully at this point in time. If you're following along, by this time you have the bronze loaded, but we need to look at silver initial load, incremental load, and SK update. So all these scripts I'm chaining together, and that would be our patient dimension pipeline. And in the master pipeline, our first pipeline that we need to invoke would be the patient, because only when the patient table is loaded, right, so we'll have the patient IDs, unique patient IDs, which we can reference in the other tables like bed allocation or be it resource allocation. So any other operational table that you would want to load should reference the patient table. So that should be our first pipeline that you need to invoke, and then the admission discharge pipeline, and then we have bed allocation script, then resource allocation script, and finally loading the FactPatientAdmissions notebook as well. Okay, so we'll revisit this. For now, I just wanted to let you know the flow and the master pipeline that we have built. So please keep this in mind. We will revisit this later on. We close all of this pipelines. Let me come back to workspace and let me open the admission discharge scripts folder. Let me open the admission discharge silver script. So we'll quickly look through it. So we have the PySpark SQL. Let's quickly run through the notebook. It's not very extensive, so we are going to keep it very simple because in the bronze table already we have taken care all the logic already to make sure the data is reliable, and we ran through SQL scripts as well to make sure there is no overlap, the distribution is smooth with monthly caps and so on and so forth. So here we are just going to enrich the bronze layer with few columns, like a feature engineering you can say, and then we are going to just quickly load the silver table. Okay, yeah, so we are importing the PySpark SQL session, and then the required functions I'm importing, like date, diff, call, when, year, month, quarter, and current date. Initializing the Spark session, and then we are reading the clean admission discharge bronze table. Okay, this is already clean. We have ran through the scripts and we make sure the data is quite reliable. So we are going to use Spark read format, delta, and then reading the table and keeping it in data frame. And we are going to do some basic cleaning and enrichment transformations. That's all. Okay. And because our patient table, patient SCD type 2 transformation scripts are going to be very complex, so we'll go through it line by line. So after this session, so basic cleaning, we are just going to, using the with column, we are going to have admission status. So we are defining a condition when the discharge date is none or null, then the admission status is going to be active, otherwise the patient is discharged. As simple as that. And the length of the stay we are going to calculate with the date diff function between the discharge date and the admission date. So that is going to, and it shouldn't be null, and that will give me the length of the stay for any patient. Okay, otherwise we are keeping it as null. And admission year, month, and quarter, we are just going to simply pull using the PySpark SQL functions year, month, and quarter with the call function. We're passing the admission date and extracting all these three metrics individually, year, month, and quarter. That's all. And once we have the silver admission data frame, so optionally you can deduplicate records as well if needed. Okay, so dropping duplicates based on patient ID, admission date, and diagnosis. You can drop duplicates if any, but I don't think we have any duplicates as such. But you can just run this as well if you need to deduplicate. And then finally we are just writing it to the silver table, admission discharge silver table. That's it, in the delta format, and then we are overwriting it and we are going to partition it by diagnosis. So the bronze table also we partition by diagnosis. Here we are partitioning by diagnosis again, and then it is loaded. So let's have a quick look at the silver table that is loaded. So by now you should have both bronze and silver admission discharge table loaded perfectly. Let me open the Lakehouse quickly. So let me open the admission discharge silver just to have a quick preview. The preview is taking a bit of time, so maybe that should be reported to Fabric team, I would say, because the preview for 1000 records shouldn't be taking this much of time, so it's taking a bit longer. Okay. So here you have the admission ID, patient ID, what key, admission date, discharge date, right? So diagnosis, so everything we have already performed the required validation. So what extra we have did here, we enriched the data with the admission status. Okay, so whether the patient is discharged based on the discharge date. Okay, and then the length of the stay we have calculated, as you can see, and you can cross check whether it is reliable. Okay, between the, just calculating the difference, that's it. And admission year, month, and date is also something we are just kind of storing it. Okay, but that's all we did. Okay, so I think we have already performed the required validations to make sure our data is reliable, and in silver transformation we're just enriching it with few columns. Okay, so that's all it. So maybe you can validate the admission status, the distribution of admission status. Probably you can run some queries. That could be your probably homework. You can run some queries, group by the admission status, and see how many patients got discharged and how many patients are active across these 6 months. That kind of validation, we can always run it in the SQL Analytics endpoint and go through it. Okay, so I think that's a wrap for this video. I think in the next video, what we will do is we will run through the bed allocation script on top of the, by extracting the admission period for any patient from admission discharge silver, and then we'll run through the bed allocation notebook in the next video. So thank you. I will see you in the next one. Thank you. And welcome back. So in this video, we will quickly look at the bed allocation data ingestion. Okay, so let me move on to Fabric portal real quickly, and we are in the workspace. So let me move on to bed allocation scripts folder and load the bed allocation script. So as usual, make sure you attach the data source, the data item, which is your Lakehouse, because at the end of the script, we are going to load the bed allocation table into our Lakehouse. Okay, let me minimize this. And as usual, since we are using Faker library to synthetically generate the data, make sure you pip install the Faker and import the required functions, datetime, SQL types, and random as well. Okay, and let's quickly run through the notebook. It is a bit extensive, but we will get there. Okay, I'll try to explain as much as I can, so that you can go through the notebook and run it yourself, and probably if you have any questions, you can comment in the lesson below. Okay, right, so we are initializing the Spark session and Faker, and then what we are trying to do here is, as I mentioned, we're just going to read the admission discharge silver table to get the admission discharge period for patients. Okay, so we're going to rely on silver. That's the reason I wanted to first show you the silver transformation script for admission discharge, and then we need to move on. So as I already mentioned, the bronze table itself is quite reliable, but we added we have made few enrichments to the silver table, and then it is ideal to consider silver table and then probably read from the silver table and then move on. Okay, so we cannot rely on the bronze layer in medallion architecture, right? So silver is kind of the transformed clean data that I can rely and move forward with my bed allocation ingestion. Okay, data ingestion. So I'm storing it in ADM data frame after reading the admission discharge table, and then ADM data, I'm just going to select the patient ID, admission date and discharge date, and the what key, and then I'm using collect function and storing it in ADM data variable. Okay, so and we are going to build a list of admission records. Okay, so each record is a dictionary with patient ID. So in the list, you will have patient ID, admission discharge date, and optionally the ward as well. So we are going to have all those 4 columns in that list. So we are just going to iterate through that ADM data and keep adding it to the ADM list. So that will have kind of a dictionary kind of set with the patient ID and the respective value for those. Okay, in the list. Yeah. So number of records, we are going to, you can tweak this to 100,000 or 10,000, and you can generate as many bed allocation records. Okay, so the synthetic data that you want. So here we have it as 100,000, and error probability, I'm not going to simulate any error. I think probably we may need to fine tune the script if you want to inject any error and simulate, but to keep things simple, I'm not going to have the error probability here. We can delete this to avoid any confusion. And bed records, we are initializing the list, okay, empty list, and then today's date using date time we have already imported. We are getting today's date, date today. Okay, now comes the actual implementation for realistic simulation, right? So we are going to generate one bed allocation record per admission record for a patient. Okay, so that's the thumb rule that we are going to set here. So for every admission record for a patient, we are going to generate one bed allocation record for that particular admission for a patient. Okay, and there is a possibility you can probably, if you want multiple records per admission, right? So if you want to generate multiple bed allocation records. So patient may got admitted and then they switched the beds, right? So they have been allocated to more than one beds. It's possible, right, in a real world setting. So if you want to simulate that kind of scenario, it is still possible, but this script is built only to generate one bed allocation record for a particular admission period for a patient. Means like if a patient has more than one admission, let's say, right, in different timelines, still that patient will have two bed allocation records. That's the idea, for one bed allocation record for every patient admission record. Okay, and if you want to in case simulate multiple records, then you need to loop more than once per admission, and I'm not going to simulate that here, but that could be a probably opportunity for you to explore further, I would say, and then try to simulate. That could be your homework, I would say, on top of this script. Okay, but we are going to stick to one bed allocation record to keep things simple, and let's run through this logic. So we have the admission list that is already loaded from the silver table. We have it ready, and we are going to iterate through every record on the list, and we are going to fetch the patient ID, admission date, discharge date, and then the what key. And in case of the what key is not available, we are going to randomize it. Anyway, it's going to be 4 wards we are looking at, and we will keep that way the what keys. And what we are trying to do here in this block, so we're going to determine the upper bound for the bed allocation admission date. Okay, so if the patient, if any patient has discharge date and it is before today, okay, we are going to use it. Otherwise, we are going to default it as today's date. As simple as that. So the upper bound for bed allocation admission is going to be if the patient discharge date that we are storing here from the silver table for any patient. For that particular patient, since we are iterating here, so patient discharge date, if the patient discharge date is not none, and if it is less than today's date, okay, so we are going to keep it as patient discharge date. Otherwise, we are going to keep it as today's date. Okay, that's going to be our upper bound. Okay, because we need to define the upper bound and lower bound, and we need to generate the bed allocation record within that range, upper and lower bound, right? So the generating the bed allocation admission date. What we are going to do, if the patient admission date is greater than the upper bound, then we are going to keep the bed admission date as patient admission date itself. Okay, so it shouldn't be greater than or equal to the upper bound that we are trying to retrieve here. So if the patient admission date is greater than that or equal to that, the bed admission date is going to be the same date when the patient got admitted. Okay, else what we are trying to do, we are having a try and catch block, except block, and bed admission date, we are going to use the date between dates in fake library, and the start date is going to be the patient admission date and then the upper bound. So the lower bound is actually the patient admission date itself when they got admitted, and the upper bound is going to be what we derived here, right? So it is going to be the patient discharge date if they have, and if it's less than today's date, we have a condition, otherwise today's date. So the upper bound could be today's date as well. Okay, so that's how we are defining our logic to generate the bed admission date. Okay, so with the lower bound as patient's admission date, the upper bound we are deriving from the patient discharge date. So for every patient admission record, we are going to have one record with the admission, with the bed allocation admission, and then the bed allocation ending date. Okay, so that's what we are defining, and then building our bed allocation admission date. Okay, and then let's look at the bed allocation discharge date. How are we trying to define that? If the patient discharge date is not none, that's the first check. Yeah, it shouldn't be none. And we are going to define the lower bound for bed discharge. What we are doing, so the lower bound is going to be 1 day after the admission date, bed admission date. Okay, so that's what we are trying to do here. Bed admission date is already derived, and we are using date and time delta, days is equal to 1, which means the lower bound is going to be 1 day after the bed admission date. So these are all the checks we need to make sure. Otherwise, you cannot rely on the data that you're generating synthetically. And since it's a healthcare domain, it is tricky to work with or do some POCs on top of the real data, right? So that's exactly what we're trying to do, generating the synthetic data, and we need to make sure we keep all these checks in place to make sure the data comes out as quite reliable. That's it. Okay. And if the lower bound is greater than the discharge date, we are going to assign the discharge date as bed discharge date, and or else what we are doing is we are going to generate that date between dates using fake. And the lower bound we have already decided, which is going to be 1 day after bed admission date or bed allocation date, and then the upper bound is going to be patient discharge date. Shouldn't be greater than that, right? So it shouldn't be within that period, right? When the patient got admitted and discharged. So that's exactly what we're trying to do. So the bed admission date and bed discharge date should fall exactly within the timeline for that patient admission record. Okay, so otherwise, it doesn't make sense if it falls outside of the range, right? So we need to realistically simulate this to make sure there is a bed allocation occurred for any patient within that particular admission period for that patient. And even if they have multiple admissions, they'll have 2 bed allocation records falling within that range itself. Okay, so let us move on. So if the patient is not discharged, and if the patient discharge date is, let's say, none, has not been discharged, he or she, we're going to again optionally, just for simulation purposes, we are going to optionally assign a discharge date with 50% chance. This you can do it, or yeah, I think you may also stick to this logic, what we have here. But the else part I'm just handling just to showcase how we can optionally assign a discharge date with 50% chance, and probably in case of any data quality issues in a real time. So you may probably want to amend or manually assign a discharge date and handle those data quality issues. So just for optionally, we can assign a discharge date with 50% chance using fake boolean. And the lower bound for bed discharge, again, it is going to be 1 day after bed admission date, and we are going to try the bed discharge date, which is between the lower bound, which is 1 day after bed admission date, and the today's date. Okay, and that will kind of amend or update the 50% of records when the patient discharge date is not there. Okay, so just to simulate and showcase how we can also take care of such manual updation, or what you can call to have that probability, 50% records, you can amend it as well. So just to showcase that kind of scenario, in case if you want to optionally assign a discharge date with 50% chance. Else the bed discharge date is still none, which means the patient is going to be still active and has not been discharged. Okay, let's move on. So now finally we are going to build the bed allocation record with the what key. Bed ID is going to be fake, unique ID, then patient ID we have already extracted, the admission date and discharge date for the bed. Okay, not for the patient. The bed admission and bed discharge date is assigned here, and the bed dates, it's going to be a randomized element whether it is occupied or available. Again, I think it shouldn't be the case. We shouldn't randomly assign the bed status as occupied or available, but I think for the sake of this demonstration I've randomized it. But it is a good opportunity for you to work through, and I think we should ideally look at the discharge date here, right? So based on the discharge date, you should define the bed status. It's a simple change that you can tweak the code, and I will I will assign that as your homework so that you can tweak the code and let me know how that works for you. So I think if the bed discharge date is none, then you can say the bed is still occupied, the patient has not been discharged. And if you have a bed discharge date, which means the bed status is available. As simple as that, you can do that. And we are appending the bed records to this list what we have initially where we have defined bed records list. Okay, so that we are appending, and this loop will iterate until we have the bed allocation record for every patient admission record. Okay, and then we are defining the schema here. What key, bed ID, patient ID, admission date, discharge date, and bed status. And then finally we are creating a data frame using the schema and the bed records list, creating a data frame, and then we are storing it as bed allocation in DBO schema as a delta table, and then partitioning it by what key. Okay, that's all about the bed allocation script. So if you have any questions, feel free to comment in the lesson below. And as I mentioned, there are few optimizations that you can do to make it even more realistic. The bed status, which is currently randomized, you can look at the bed discharge date and then assign the bed status accordingly, either occupied or available. If you have any questions with the implementation, let me know. I'll be happy to assist. Let us quickly look at the table that got generated. Okay, so let me open the CareOps Lakehouse. Let me open the Explorer and bed allocation delta table, and it is partitioned by what key. Okay, so you can also look at the files and make sure it is correctly partitioned or not. So let me have a look at the preview quickly, and we will run through some SQL queries to make sure if the validation we'll perform those validation to make sure the bed allocation record is correctly generated, right, for every patient admission. So here you have the what key, bed ID, patient ID, admission date, discharge date, and bed status, all that we have. So maybe let me quickly move on to the SQL Analytics endpoint, and let me open the query bed allocation bronze checks. It is not actually the bronze, it is going to be a single table that we are having for bed allocation. Yeah, okay. So here I have some few scripts that we will quickly run through to make sure our data is reliable as well. Okay, so we have already ran through some scripts for admission discharge, but let's do this for bed allocation. So we are just going to count the records where discharge date is present and occurs before admission. The same check what we have done for admission discharge. So we are having an aggregation with the case statement when the discharge date is not null, and when the discharge date is less than the admission date, then 1. So it cannot happen by any chance. It should always be greater than the admission date, discharge date. So if we have any, then we are having inconsistent date records. So let's have a quick look at it. Going to run this query. So we have total, I think, yeah, so I simulated with not 100,000. You can tweak the number of records. It's 10,000 records, and we don't have any inconsistent date records. That's perfect. Let me move on. In case if you have any inconsistent records, let's have a look at it in detail. Okay, so and then probably troubleshoot further. Okay, now comes the critical part. So as I mentioned, we need to make sure we have a bed allocation record for each patient admission record. So that's the goal, right? So that we need to validate for sure. So what is the script we have here? So we are going to validate bed allocation against the patient admission data. So that's very, very important. So we have we are joining the bed allocation with the admission discharge silver on patient ID and admission date. We on the admission date, so b.admission date, which is the bed allocation admission date, is between the patient admission date and then the discharge date. So that's the check that we need to do. So that's the condition that you need to perform. Okay, even when we join, we are joining on the basis of patient ID, and the b.admission date is between the patient admission date and discharge date. Okay, and we are using query list to just get the date, today's date, in case if it is null. Okay, that's what we are trying to do. And we have some conditions in the where clause. What we are trying to do, any record that does not satisfy this condition might be inconsistent. So what is that condition? If b.admission date is less than a.admission date, so that's the check that you need to do in the where clause. So the bed allocation date or the bed allocation admission date, if it is lesser than the patient admission date, then that is not right. You have a problem with your data. Okay, so the data is not generated correctly, I would say. And we have OR condition, right? So here we are checking if the discharge dates in both the tables are not null, and if the bed allocation discharge date is greater than the patient discharge date, then that is also not right. So that's why we have a couple of conditions here. Okay, so here I think this condition in the join is crucial. Otherwise, we may run into a problem if let's say a patient has multiple admissions. When you perform join on the patient ID, you will have problems. That's why we're trying to also make sure the join is happening based on the admission date from bed allocation, and that falls exactly within the patient admission. So as I mentioned, if there are multiple admissions for any patient, we have generated one record for each admission record for patient. So when we perform the join, we need to make sure that bed allocation admission date is correctly joined with the respective record, I would say, in the admission discharge silver table. Okay, so that's why we have this extra condition to avoid any further problems. And here I think the condition, so the bed allocation, if it starts before the patient admission, then it is an inconsistent record that we need to capture, or the bed allocation ends let's say after the patient discharge, that is also inconsistent. So that's why we are capturing both the conditions that you can see here, whether the bed allocation starts before the patient admission or bed allocation ends after patient discharge. Both are inconsistent scenarios. So let us run this query and validate the bed allocation against the patient admission data real quick. Run this query, and if this returns 0 records, then you're in a good place, I would say. Yeah, so this tells us the data is quite clean and reliable, and we don't have any inconsistency in the data that we have generated for bed allocation. So I will share the bed allocation, the SQL script as well as the notebook in the same lesson, so that you can follow along, and let me know if you have any questions. I'll see you in the next one. Thank you. Hi and welcome back. So we are in module 4, and in this video we are going to cover implementing SCD type 2 for the patient dimension, and that's going to be our patient info silver table. So let us jump on to Fabric portal real quick. So here I'm in workspace, so I have a separate folder that you can also create. So you can always create some folders and then maintain your scripts within the folders inside the workspace, and that will be bit organized for you to quickly navigate to scripts, right? So under patient SCD type 2 scripts, the bronze initial load, we have looked at it. So we'll quickly look at 3 different scripts: the silver initial load, then incremental load simulation, and then the SK update. Okay, so we'll go through one by one. Let me open the silver initial load. That is not a massive script, it's quite quick. And then in the incremental script, we need to spend some time, understand what we're trying to do there. How are we simulating the updates and inserts there? Okay. So here we are importing the required functions, the current date, and I'm importing lit. I'll tell you why I need lit function from PySpark SQL. Then I'm initializing the session, and then we have the bronze table and silver table names we are defining, and then we are reading the bronze table into the data frame. And I think all we are trying to do is we are just trying to transform the raw data into a SCD type 2 table fields. All we need is effective start date, end date, and it is going to be open ended. Okay, the end date, and then current record. This current as flag is going to be 1, which is an active record, and that's why we are going to use lit function to set the constant value for so which means like all the records that we currently have in the bronze table, we are going to take it to silver table as current records. As simple as that. And we are using with column function, and then effective start date is going to be the current date, and end date is going to be lit of none, which means we are going to keep it as null when we cast it as date, and we are going to keep it open ended for now, and you can even provide any future date if you want. Okay, so not a problem. And we are finally storing the silver table in a delta format, and we are overwriting it in case if we already have it, and we are storing the patient info silver table. Okay, so this is the initial load script. We are transforming from bronze table. In the bronze table, you won't have your the timeline fields as well as like a flag, current flag. All we are doing in this script is just establishing those. Let us move on to the incremental load script. Okay, so we are just going to simulate the incremental load to bronze and silver. So we are looking at 2 different parts in this incremental SCD type to load. Okay, so that we're trying to simulate here. So the first part is going to be the incremental load into the bronze table that we've already built. It generates the raw incremental records. We can define the proportion, how many updates you want, updates and insert using Faker, and writes them to the bronze table. Okay, it doesn't include any SCD columns, as you are aware by now. Okay, and part B is going to be, let me move on. Part B is going to be from the bronze to silver. The SCD type to merge will happen. This script reads the incremental records that we have done in the part 1 from bronze table and transform them to include SCD type to columns, and then merges the data into the silver table. Okay, so that's what part B does. Okay, so we'll go through it. So it's a bit extensive script. We'll quickly go through line by line. Let me come to top. So make sure you install the pip install Faker library, then import the required functions, SQL types, as we already do, and instantiating the Spark and Faker session. And we're defining the bronze schema. The same schema, the raw ingestion, for the raw ingestion, we need to define the schema that we already have defined when we are building the bronze patient info table. Okay, so patient ID, name, age, gender, marital status, diagnosis, last visit date, and ingestion timestamp. And we have the load date as the ingestion timestamp for this incremental batch. Okay, so the load date, we're going to keep it as current date. Okay, using Spark SQL function, we're getting the current date. Using the current date function, we are collecting it, storing it as current date, which is our load date. Okay, so we have the bronze table defined, and then what we're trying to do is we are trying to read the existing raw data from bronze table to simulate some updates. Okay, so that we need to do, and then we can also simulate the insertion as well. Okay, so the simulation parameters we can define here. We'll come to that because how many records you want to update. 20% of the batch are updates, and then the rest, let's say out of 1,000 records, I wanted to incrementally ingest into the bronze table, and out of that 100 records, 20% is going to be the updates, and remaining 800 records, 80% is going to be my inserts. That's how we are going to define the simulation parameters. But before that, let's try and get the existing bronze data frame, and then the existing patient IDs. We are going to collect the existing patient IDs from the bronze table. Okay, so we are selecting the patient ID, distinct of patient ID, and collecting it and storing the existing patient IDs. Okay, and we are the exception is also handled here in case if there are issues. So the simulation parameters, we spoke about it. We are going to simulate 20% as updates and 80% as inserts, and we're defining an empty list incremental data. So we have a couple of steps here. Step 1 is going to be simulating the updates for existing patient for the raw data, and then we are going to simulate the new patient inserts as well. Okay, so we are going to flow through this data to bronze. Okay, we are going to flow through and ingest into bronze the simulated data, the updates and inserts, and then we need to flow the data from bronze to silver table. Okay, our SCD type to table. So both we are going to handle it. That's why we have two different parts, as I mentioned. So in this part, we are going to incrementally load into bronze, and that doesn't have the SCD columns. So in the next part, we will flow the data through silver from bronze as well. Okay, we'll merge the data there as well. Okay, so that's exactly what we're trying to do since we have the medallion architecture here, bronze and silver layer. So we're going to simulate this in bronze, and then we merge into the SCD type to table in the silver layer. Okay, so step 1 is going to simulate updates for existing patients, the raw data. The existing patient IDs we have already collected here. So we are going to iterate. Okay, so in the step 1, we are checking if the patient IDs is available. Okay, before we even iterate, and then the update IDs, we are going to randomly sample from the existing patient IDs, and we are saying the minimum of number of updates. The number of updates is going to be 20%, as I mentioned. Okay, and we are using min function and passing the argument 1 as the number of updates, which is going to be 20% of the records. Okay, out of let's say 1,000, it is going to be 200 records, and the length of the existing patient. So using the min function, we are going to let's say randomly get the patient IDs, existing patient IDs, which is going to be out of 1000 records. I'm going to get 200 records from as my update IDs, okay, from the existing patient IDs. That's how we are simulating the updates. And we are creating a dictionary for fast lookup of existing fields like the name, gender, age, and last visit date. So we are having a variable called dictionary existing patient info, and then we are calling dictionary class, and we are passing the existing bronze data frame, and we are selecting all these, and we are using this rdd.map function to collect and then store it as dictionary. Okay, store it as dictionary. So I think at the end of this, you will have the patient ID as your key, and then the respective values as name, gender, age, and last visit date. It's for faster lookup. We are creating that dictionary using the RDD map function, and then collecting the information for every patient ID and storing it in existing patient info dictionary. Okay, so now comes the iteration part for patient ID, PID, and update IDs. Okay, so the update IDs. We are iterating through each and every patient record. We are retrieving the existing details for this patient using this dictionary that we have defined. We are using this get function, and we are passing the patient ID from the update IDs. Okay, and then if the existing values are present, what we are doing, so current name, current gender, existing age, existing last visit date, we are fetching from existing values. Okay, so that we are already got the values here, right? So we are just trying to get those values for this patient. So the dictionary is quite easy for faster lookup. That's why we are having this dictionary created, and then we are iterating, getting the values for every patient and then iterating through it. And we are trying to generate a new age. So just for the simulation purposes, for update simulation, we are randomly assigning the new age between the existing age that we got here and then let's say 90. So between that range, it will randomly assign the new age just for simulation purposes, update simulation. And we are generating the last visit date that is strictly greater than the existing date. So these are some of the checks that you need to make sure. So we already have the existing last visit date for the patient, and you cannot randomly generate, or the date cannot be lesser than the last existing visit date. So it should be strictly greater than the existing last visit date for a patient. So that's what we are trying to do here. If the existing last visit date is not none, we are trying to increment the date by 1. Okay, and we are passing the function for, we are defining the format as well as year, month, and date as well. That will have my start date string. Otherwise, we'll if the fallback is missing, it should be none. Okay, and if we have the value, so what we are trying to do, date time function using date time strp time, we are passing the start date string and the format dot date. That will get me the start date object. Otherwise, it will be today's date, start date to last 2 years. We are falling back to it. Okay, so get today's date as the date object as well. Get the today's date, and the new last visit date is going to be, we are using as usual the date between dates from fake function, fake instance. We are using date between dates function, and the range is going to be start date object and today's date. Okay, and that will define the new last visit date for patient. And this is purely for the simulation purposes. 200, the 20% of the records I'm going to update the data for existing patient ID. So what are the fields that I'm going to update? The age as well as the new last visit date. Okay, and then we are building the record, the existing patient ID. The name, we cannot simulate update for a patient name, right? So it is not realistic. So we are going to use the existing patient name and gender. So name and gender cannot change. We cannot simulate any update on name and gender. That doesn't make any sense. So we are trying to simulate the update for age and the last visit date. Okay, new age and new last visit date. Marital status and diagnosis can still be randomized. Okay, it can be from married to single or married to divorced or widowed, so that is okay, we can randomize it. Diagnosis also can be randomized. The patient got diagnosed with cardiology and now they got diagnosed with a different probably orthopedics or neurology, so that is also fine, it is possible. But name and gender we cannot play with. Age will change, and we also make sure the age also we are keeping a check. It cannot be lesser than the previous age, right? So that doesn't make any sense to us. We need to get the existing age, and it should be any date, any age between those existing age and 90, let's say. Okay, so that's what we are trying to simulate, and we are trying to append the record to the incremental data list. Okay, so that's our step one, to simulate the updates for existing patient. 20% of the records, let's say out of 1000 it is going to be 200 records from our simulation parameters, that's going to be our updates, and 800 records it is going to be the inserts. So let us look at the step 2 simulation quickly. So we are looking at the new patient insert. So number of inserts it's going to be, we are iterating through those 800 records based on the simulation parameter that we define. The patient ID, it's going to be a new unique ID, since it's going to be a new patient record that we are simulating to insert as a part of incremental load. And record, we are defining the patient ID, and name, age, gender, everything can be randomized since it's a new record that we are trying to simulate to insert. And last visit date, everything we are simulating to make it as a new record, and then we are appending that as well to incremental data list. Okay, and by now you should have that incremental data ready, and then we are combining both update and insert, and that will be like 1000 records that we are going to incrementally push to the bronze table. And I think we are not overwriting as such, we can't overwrite the data, so we are going to append the data to the existing bronze table. Okay, so that's why you can see the format is delta, and the mode we are going to make it as append, and save as table we are passing the bronze table. So that will incrementally load the records, 1000 records with 800 records inserted, simulated, and 200 records is going to be updated for the existing patients. Okay, and we are also printing the incremental raw load is complete, 1000 records appended to bronze table into the patient info bronze. Okay, so that's our part B, where we are simulating the incremental load to the bronze table. And we will now look at the part B, where we are transforming the data from bronze to silver with the SED type to merge. Okay, now quickly look at part B, the transformation from bronze to silver SED type to merge. So this script actually reads the new incremental raw records, right? So that we have in the bronze table based on the let's say ingestion timestamp, the load date, and transform them to include the SED type 2 columns, and then we are going to merge it into the merge the data into the silver table. Okay, so let's see how we can do that as part of part B. So we import the PySpark SQL session, then functions, and also make sure you import the delta.tables, import the delta table. Okay, so that's for the update purposes. We are going to need this delta table library from delta.tables. Initialize the Spark session with the app name of your choice, and define the table names and the load date, and we are going to read the incremental new records from bronze table. How are we going to do that? So Spark read format delta, and the table we are passing the bronze table. Okay, and we are going to filter it based on the timestamp. Okay, and the timestamp, the ingestion timestamp is going to be today's load date. Okay, the current date. So it will only extract the incremental data that we have just inserted into the bronze table in the part A in the previous script, previous block of code, right? So we'll have that stored in incremental raw data frame, and we are going to transform it for silver table with the required columns for the SED type 2, start date, end date, and we are casting it to none. With the lit function we are keeping it as none and casting it, and then all those records we are going to keep it as again the current record, right? So those 100 records, sorry, 1000 records. Now we are going to read the current active silver records from silver table, okay, and store it in silver data frame, okay, and we are going to filter, apply the filter and the current flag, and get only the active current records from silver table and store it in data frame. Okay, so that's, I hope that's clear till now. And we have a couple of steps. Let's quickly go through that. And as a part of step 1, what we are going to do is we are going to identify the update records. Okay, so the incoming records from the bronze table, the incremental data that match an active record and have a change in the key attributes in the silver table. That's going to be an update. And as a part of SCD type 2, what you ideally do is you need to expire that record which is there in the silver table, and we will insert a new record which is an updated version for that particular record. Okay, that's exactly we are going to simulate in these 2 steps. We'll see how we can do that. So we assume, as I mentioned, the fields like age, diagnosis, marital status, and last visit dates are the ones we are going to update. Okay, and that's exactly we are going to check, because name and gender are assumed to be static without any changes. So we wanted to track the changes for those. Okay, and updates data frame, transform data frame. So we have the transform data frame here from bronze table. We are aliasing it as bronze and joining with the silver data frame on patient ID, and we are performing an inner join. Okay, so you can still write a SQL query, or you can still achieve this with PySpark within the data frame, and you can perform the required join and say it's going to be inner join between those 2 data frames. And we are going to filter. Okay, so once we perform the join, we are going to filter and see the join condition is based on patient ID, and then we are trying to see if the silver.age is not equal to bronze.age. So all those 4 attributes we are checking using OR condition, whether there is a mismatch, right? So whether there is any update coming in. Okay, and we are selecting all the records from the bronze table. So that updates data frame, we wanted to build it by joining with the silver table based on this filter. Okay, and keep it ready. So that will identify the update records when there is a match in the silver table and have a change in any of the key attributes, these 4 attributes. Okay, and step 2 is to identify new record. How do we do that? So it's very simple. So from the transform data frame, we are going to join, we are going to do a left join from the bronze transform table into the silver table. That's exactly what we are trying to do here. We are joining with silver table, and when we say left anti, it will identify the records with patient ID not found in the current active silver table. Okay, so those are the tables on the left side in my transformed bronze data frame that needs to be inserted into the right table, which is our silver table. So when you use left anti, you'll be able to identify those new records on the left table. Okay, so and we are storing it as new data frame here. And step 3, we are going to update the existing silver records for updates. Okay, so in the silver table, so we have the update IDs already stored here in the updates data frame. So we are going to get the update IDs, which means like we are going to iterate through that updates data frame and collect the patient IDs, distinct patient IDs, and store it. Okay, for patients that are being updated, mark their current active record as historical. So in this step, all we're trying to do is we are going to expire the current record. Okay, so since there is an update coming in that we are trying to simulate, so we need to expire the old record and then insert the updated version for that patient. So step 3 will handle the updation to expire the record. So when you expire the record in SCD type 2 setting, you need to end the timeline. Okay, so here we are trying to end the timeline with lit current date, and we are using lit of 0, which expires the record itself. And we are getting that update IDs list. Okay, so here once you have the patient IDs, we are trying to get the update IDs list, and the table path, you can always get the table path. So here we are looking at patient info silver. Let me quickly show you how we can get that. So if we move on to Lakehouse quickly, CareOps Lakehouse, So if I wanted to get the table path for, let's say, patient info silver, so I'll get the properties, get into the properties, and here you can see the URL, okay, or relative path, ABFS path. So I think this is the path you need to take, ABFS path. You can copy to the clipboard, and if I come back to the script, so you can see that's the path I'm pulling. You may need to copy that path and bring it here for the table path. Okay, so for the update purposes. And silver delta, as you remember, we imported the delta table from delta tables library that we are going to use now. Delta table for path, using for path function, you are passing the Spark session and then the table path to get the silver delta. Okay, so silver delta table, and all we are doing is once we have that stored here in silver delta table, we are trying to update that delta table directly, okay, using this condition where the patient ID in the update IDs list. Okay, so that's the condition we are passing. If the patient ID falls within that list, so all those records we are going to update. And what we are going to update, we are using the set by updating the effective end date to current date, and then we are using lit of 0 for this current. So basically we are trying to expire the record for those patients, so that in the next step we'll be inserting the new versions in the silver table. Okay, and we are also printing how many records got updated. Okay, updated existing silver records. So at the end of the execution, you can see updated existing silver records for 200 patients. So that we are looking at the length of the update IDs here. Okay, so to print and check whether we are correctly updating the 20% simulation parameter that we have set initially to update those records for the patients. Right. So let us move on. In the step 4, we are going to insert the new versions into silver. So what we are trying to do, we have the updates data frame. Okay, so which is here. Okay, and then we are going to union with new data frame, because here in step 3, all we are trying to do is we are just going to expire the existing record in silver data frame, right? But we need to insert the updated version for those expired records, and also the new records as well, which comes close to 1000 records, that we have initially set as simulation parameter, that we need to insert into the, or merge into the silver table as such. So the new versions data frame will combine, union both the updates data frame and the new data frame. The updates data frame, we have built it here, as I mentioned. So we have joined on the basis of patient ID, and then we captured if there are any changes in any of these 4 attributes. Okay, so once you combine those two, you'll have the new versions data frame, and all we are going to do is we are going to merge or append as such, right? So basically we are doing the merge here by expiring the records first, and then we are inserting the record, right? So we are not using any merge function here. So we are expiring the records in the existing silver table, and then we are inserting the update version as well as the new records into the silver table. So we are basically trying to append to the silver table with the mode append in the delta format. That will incrementally merge. So finally we are printing saying that we are incrementally merging the data. The incremental merge is complete. So new versions inserted into the silver table for updated and new patients. Okay, so I hope it makes sense and clear to you. So with these steps, we are trying to simulate. We are initially setting that simulation parameter here. So I wanted to kind of incrementally push 1000 records. Out of that, 20%, which is 200 records, is going to be my updates, and 800 is going to be my new inserts. And then we are pushing it to bronze table, and then we are merging, kind of doing the merge operation to the silver table by expiring the existing record and then inserting the new versions. Okay, so run the script. So I'll be sharing the script in the same lesson below. You can download and run through this, and let me know if you have any challenges in executing the scripts. Okay, And there is one thing I wanted to also quickly let you know. So once you are done with this incremental ingestion into the silver table, so you can do a delta time travel. There is this concept, if you're not aware, which is delta time travel. So you can also always know when you're doing these updates in the SCD2 kind of table, you can always look at the previous version and current version. So it is one of the nice feature in Delta Lake, wherein you can time travel to the previous version and see how the data looked like in the previous version and how it got updated today, right? And I have the script. Maybe you can run through the script, and all it will show you is you can see it will throw what are the versions that you're comparing, the current version with the previous version, and we're trying to take five sample IDs for comparison, and you'll have those patient IDs, and what is the previous version for those 5 patient IDs, and what is the current version, and it will also tell you the difference between the current and previous version. Okay, so what is the updated record for that patient? We are looking at sample 5 patients. You can always look at what are the changes that got amended here. Okay, so just go through the script. So it's very simple. So we are again trying to import the delta table, and we are initializing the Spark session, then table path, and as I mentioned, we are using delta table for path by passing the Spark function, Spark session, and the table path to get the delta table, and then to get the latest version, previous version, we are using time travel. How are we doing that? So delta table dot history, we are using the history of one dot select version and then collect function. So that will get me the latest version. Okay, and the previous version, if I say the latest version -1, if latest version is greater than 0, it will get me the previous version. So you can achieve that or do the delta time travel using this delta table library by looking at the history. When you say history of 1, passing 1 to history function, so you can see the synopsis or the snippet, get the information of the latest limit commands on this table as a Spark data frame. So you can get the full history, and if you pass probably let's say 1, you will get the latest version. Okay, so then you can select the version and collect it. Okay, so and you can say the comparing the versions, the latest version with the previous version, and the current data frame. So this is where the trick is. Okay, so how are we going to fetch the data for the current data frame? You need to say dot option version as of, you need to pass the latest version. Okay, and then load table path. So the option version of will get you the latest version or previous version. Okay, so here we are just kind of trying to get that version, the latest version, by looking at the delta table's history and collecting the version from the delta table history and storing the latest version, and then we are kind of keeping it as -1 to get to the previous version. And then here is where the actual data we are pulling based on the option version of, and then passing the version will get you the current data frame and previous data frame using the delta time travel. Okay, that's a nice feature, a nice capability to look at the previous version and see how the data looked like before, and you can do a time travel to the previous version, or even if the updates are like, if you have like 10 versions, you can still go to the first version of the data and look at the data, right? You can read more about it with respect to delta time travel. I will probably share some links in the same lesson for you to read more about delta time travel. So sample IDs we are picking, just go through the script. It's not a big deal. You can quickly go through the script, and all we are trying to do is looking at sample 5 patient IDs and see how the previous version looked like, and what is the update that we have handled, because we are trying to simulate the SCD type to here, right? So just to validate, we are using this delta time travel and looking at the previous version for 5 patients and the latest version which we have just incrementally updated for those 5 patients, and then we are looking at the difference as well. Okay, so just go through the script. In case if you have any questions, feel free to let me know so that I can assist you further. All right, so I think when you pick the sample IDs, just probably you need to make sure the previous data frame you are applying those filters, required filters, and limit it. Okay, make sure you are doing that, and looking at the sample 5 patient IDs. Okay, so that you can probably validate if your ACD type 2 simulation is working fine or not. Okay, so it is already validated. Maybe you can look at few samples. You can look at larger data set as well if your ACD type 2 logic is working fine. Okay, that's a wrap for this video. Probably we will quickly look at the SK update in the next video. Okay, so one thing to quickly note, yeah, so I missed to mention that. So because since you're incrementally ingesting 1000 records into the silver table, so when you're looking at the delta time table, you make sure you pick the sample patient IDs where the effective end date was updated in the previous version. Okay, so we need to keep that filter for row in previous data frame filter. The effective end date is not null. So that's the check you need to do to make sure you are looking at the recently ingested or incrementally ingested records. You're picking 5 samples from the 1000 records that we incrementally ingested. So that's a point to note. Otherwise, if you're not keeping that filter, you may look at a different sample and you may end up with some problems. So those 5 samples that we're looking at, we need to make sure it is in the data set which we recently ingested incrementally. Okay, well, now I think at this point we have incrementally ingested the records, the simulation parameters that we have set, 1000 records into the bronze, and then we took it to the ACD type to silver table, and then we also looked at delta time trial to see how we can validate different versions in your delta table, right? So that we have looked at. Now I think the critical part is let us look at this SK update script, and then I think we can wrap up the patient pipeline, so that we have here. So I'll probably you can build this pipeline as I mentioned under data pipelines. Sorry, not admission pipeline. Let me close this. Let me open the patient dimension pipeline. You can see there are different scripts like the bronze initial load, and then we looked at the silver initial load, and then the patient incremental load, which is pointing to that notebook we have just gone through in detail in the previous video. So all you have to do is select the workspace and then point it to that notebook. And this is in order: initial load, bronze, silver initial load, and then incremental load. And finally, we need to do this SK update, which we are going to look at now. So you can build this patient dimension pipeline, and you can run it end to end and see if it works fine. Okay, and then you can perform those validations as well. Okay, if I come back to SK update, so it's not a lengthy script, but I'll let you know the logic that we're implementing for this surrogate key implementation in patient dimension. Okay. So the idea here is, let me tell you the idea. So as I mentioned, we are going to surface in the reporting only the latest position or latest snapshot for the patient. And for that to be implemented, so see, today you may have loaded some records to the fact table, and tomorrow the patient data may get changed. Okay, so there could be some amendments to the patient records, and in reporting, you always wanted to position the latest snapshot for the patient, right? So for that, you need to implement the surrogate key, and we'll see how we can do that. Okay, so I think before we move on with the script, so what we're trying to implement here, I just wanted to illustrate in an Excel real quickly with a sample, so that it will be easy for you to understand, and then we can go through the PySpark script to see how are we implementing this in these 2 steps. Okay, let me move on to numbers. So here I have a sample, okay, just to demonstrate the ACD type to SK derivation for a patient table. So imagine you have 3 records in patient table with patient PK, patient ID, name, date of birth, gender, address, and you have the effective start date and end date and current flag. So look at this patient, John Doe. So the patient PK is 101, 102. Same patient, the first record is actually expired, okay, on 10th of May 2023, and then we have only the current record. The second is the current record for John Doe. You can see the current flag is 1. Now we have two different PKs, right? So imagine when this was the current record, okay, 101 with 101 PK for John Doe, you may have loaded some fact records, or you have probably, if you are implementing, if you're trying to cascade this PK to the fact table, you may have loaded 101 into the fact table as your keys, right, for this patient, for this particular patient keys. And I think tomorrow there is a change, okay, but I think the fact data that got loaded before 10th took 101 key into the fact table, and there is a change that came in for this patient, and there is a change in address, let's say, okay, the address got changed on 11th, and then we are amending the record, okay. And from that date onwards, when we are trying to load the fact table with the patient key, you will have 1 or 2. And the problem is when you're trying to do the reporting for this patient, right? So you may have keys attached for the records that we loaded before 10th would have 101 patient key, and then after that it would have 102 key, and we are not looking at the latest position for the patient then, right? So you may have kind of the historical address as well for the previously loaded fact data, and then from 11th the new address, and that's not what we want, right? So we wanted to always show the latest position or latest snapshot for a patient. So what we are trying to do is we are going to implement a logic for surrogate key implementation, so that when we do the reporting, we always refer the latest position or latest snapshot for that patient, let's say John Doe. How can we do that? The question. So we're going to derive the patient surrogate key using the minimum of patient PK logic over the partition by patient ID. So the approach is we are going to pull the minimum of PK and we are going to group the data based on the patient ID. We are going to partition by patient ID and then take the minimum of patient PK as our patient SK. So what that means is, so here you have the patient SK as PK as 101 and 102, and here I have an additional column that I'm deriving the patient surrogate key, and you can see the surrogate key for the patient John Doe is going to be 101, 101, which is the minimum of the PK, right? So you may have more than 2 records as well, but we are going to pull the minimum of PK for that patient. That's going to be the surrogate key for that patient, okay, so that we are storing here. And this logic we are implementing to make sure when we are loading the fact table, the patient key is going to be the patient SK that we are going to pull for that patient, okay, not the PK. In that way, I think we are going to position the latest updated record for this particular patient. So even if there is a change in address or any other information for this patient, we'll always refer the latest position or latest snapshot for this patient because we are cascading or loading the SK, not the PK. That's the idea, okay. I hope it makes sense to you. The fact sales example you can see here. I think, so let's say the sales key is just for an example, the date key, and the patient SK, you can see it is going to be 101. It will always be the patient SK that we are going to load it to the fact table, okay. So you can see the historical sales transaction for the patient, okay, P001. This patient will still reference the patient SK pointing to the latest snapshot, okay. So no updates. The goal or the key thing here is whenever there is a update to the patient dimension, there is no updates to the fact tables that are needed when the patient details change. When you are implementing this logic for surrogate key, because it always references the patient's surrogate key, and we are going to pull the latest position based on the current flag, and it will always refer the latest position or snapshot for that particular patient. So that's the idea we are trying to implement. Let me come back to the script now. I hope it's clear by now. We'll see how we can implement that in PySpark script real quick. So we are reading the existing silver patient data, okay, from patient info silver table and storing it. And step 1, we're going to add a surrogate primary key using monotonically increasing ID. I think we don't have the PK as such in the silver table. So first we are going to build the patient PK column with monotonically increasing ID. Okay, we're just going to do that first. And as a step 2, in these 2 lines of code, we are achieving the logic what we have just seen. The derivation of the patient SK using the minimum of PK over the partition by patient ID approach. So what we are doing here, we are defining the window spec using window that we have imported from PySpark SQL. Window.partition by patient ID, that's our window spec. And then the patient with stable SK, the patient with PK with column SK, and we are calling the function f dot, we are using min function, minimum of patient PK over the window spec, which is the partition, which is partitioned by patient ID. So this 2 lines of code will do the trick for you to store the patient SK, okay, for you, okay, by calculating or deriving the minimum of patient PK and then across the partition for a patient, we are going to pull that minimum of patient PK, and that is going to be our patient SK. Okay, and we are going to process that. Okay, we are going to do a overwrite, and we are saying the format is delta and option is merge schema, which is true, to the patient info silver table, and that will overwrite and merge the SK for you. Okay, and the surrogate key, both are added successfully. Okay, so you can look at the silver table real quickly in the Lakehouse to see if it is addressed. Let me open the patient info silver real quickly. Loading is taking a bit of time. Let's wait a moment. Oh, it's taking more than 12 seconds to load 1000 records. Okay, we have it. So here you can see at the end of the data set, we have the patient PK that is loaded and patient SK as well. Okay, that is loaded. So let me see if I have the validation scripts to see if the patient SK is correctly loaded, or you can randomly sample some patients and see if the SKs are correctly generated as well. Okay, so let me see. So I have some patient dim check script. Let me see that. So we have this validate SK script, so that I have here. So let me run this. So what we're trying to do here is we're trying to group all the patients by patient ID, and we are saying we're having this condition. What is that condition we are having? Once you group it, we have the patient ID minimum of patient SK as stable key. We are saying stable key, maximum of patient SK as maximum key, and then we are counting the records having minimum of patient SK which is not equal to maximum of patient SK. That's the condition we have here to validate the SK here. Okay, so the minimum of patient SK is not equal to maximum of patient SK. So this condition will tell you, so you should it shouldn't return any result set, because I think for any patient we are looking at a stable patient SK, right? So the patient SK will be same across all the records. So when you say having minimum of patient SK not equals maximum of patient SK, that condition shouldn't be satisfied, because for any patient the patient SK remains same. Okay, that's the goal that we are trying to achieve here, right? So PK could be different, but we are taking the minimum of PK and then we are surfacing that minimum of PK as our patient SK. So this should return empty, and if this query returns empty records, then your table is clean. For all the patients, it has the stable patient surrogate key. And I think the stable key, the patient SK, is what we are going to cascade to the fact table in the upcoming videos as our foreign key for patient. Okay, so that's the whole idea of implementing this surrogate key to look at the latest snapshot for a patient when you are generating some reports at the patient level. Okay, So I hope it's clear. If you have any questions on this implementation, please feel free to let me know in the comments. I'll share the script as well in the same lesson. So I'll see you in the next video. Thank you. And welcome back. So we are in module 4. We have already gone through the transformations for bed allocation script we have seen, and then we also looked in detail about the patient SCD type 2 transformation, and then we have the functional or the incremental loaded data which is available in patient info silver, so that we have demonstrated. So in this video we will quickly look at I think the validation of bed allocation is already done as a part of the second video in this module, so we are not going to validate it again. So it is going to be only the creation of couple of dimensions. We require ward dimension, so with the predefined set of values, and then we'll also look at the dim date that we are not going to create from scratch. As I mentioned previously, we can use OneLake shortcuts. As I highlighted in the architecture, we can see how we can leverage OneLake shortcuts to bring the dim date reusable dimension from other solution. Okay, so we'll see how we can do that as well. So you'll get an idea about OneLake shortcuts as well in this video. So let me move on to Fabric real quickly. And here I'm inside the workspace, and I think under DIMS folder, you can, as I already mentioned, you can cleanly organize all your scripts, pipelines, data flows, and dimension scripts, everything inside the folder. Then it will be easy to refer and quickly navigate. Okay, so under DIMS, let me quickly open the dim ward first. It's only the predefined set of values, like 4 wards. You can tweak the values and then play around, but I think we are just going to keep it very simple. We are going to look at 4 different wards in hospital. Okay, ward A, B, C, and D, and we are creating a list of dictionaries for dimension records. Okay, so for the ward key, okay, so it's going to be ward key, ward name, description. That's it. Okay, and we are defining the schema, so it is going to be ward key, ward name, and then the description. Okay, so and it's straightforward, very easy. We're creating a data frame out of it, and we are just trying to store it as delta table for the dim ward. Okay, and you can just quickly execute this. So essentially, we are trying to pull the values from this list, and then we are iterating and then storing the same for ward key and ward name, and then for description we are saying description for ward. So that's it. So to keep things simple, now we'll quickly look at the table. Then we are storing it as a delta table. So if I come back to Lakehouse, CareOps Lakehouse, you can see the dim ward is stored, and it has the ward key, ward name as same with the ward names, and then the description we are just simply keeping it as description for ward A, B, C, and D. That's it. As simple as that. And let us quickly look at the dim date dimension, how we can bring this reusable dimension from other workspaces, how we can leverage OneLake shortcuts. Okay, so here you can see the dim date is available within the solution here, and you can see there is a kind of on the top left, you can see a different icon. That means kind of a link icon, you can say. That means this is a OneLake shortcut. We referenced this table from outside of this workspace. Okay, so that's the difference you can see for the OneLake shortcut table and the other tables, and we'll see how we can do that real quickly. So if you kind of move on to, I think so you can, so here it is a schema shortcut. We are not looking at a schema shortcut. Under DBO schema, you can create a new table shortcut. So that's exactly what you wanted to do if you need to bring in the date dimension from the other workspace. So how did we bring this? I think when you're trying to create one, I think it's straightforward. It will launch a shortcut wizard, and as I mentioned, shortcuts help to quickly pull the data from internal as well as external locations. So in case if you've already built a solution, for in our case we have the COVID solution, and we have the dim date already built there. So I wanted to reuse the dim date dimension from the other workspace from my solution. So that is possible within the OneLake, or even you can bring the data from external locations such as let's say Amazon S3, or from your Delta Lake sorry, data lake, Gen2 container, even Google Cloud Storage. So those are the external sources, or internal sources within the OneLake. You can bring it as well. Okay, so if you want to bring it from inside OneLake, so it will list all the Lakehouse and the components that you can leverage. So for example, for our case, just to showcase, I'm going to bring in the date dimension or from COVID Lakehouse. Okay, so I wanted to bring it from this. Okay, so it is. You also need to look at the workspace here. So let me just get to the COVID Lakehouse in DP600 course. Click on next, and that will list all the tables and files for you. And under tables, you can see there are many tables, and I wanted to reuse this date dimension. Okay, so you need to check and go ahead, and it will show you the shortcut name and the source, and whether you wanted to create it or not. And then when you say create, it will create that link reference to that particular Lakehouse internally, and then pull it for you. And that's exactly what I did, and you can see it is connected reference to the COVID Lakehouse, and we brought the date dimension so that we can reuse it for our CareOps POC itself. Okay, so you can give a try, and in case if you require the script, probably you can create a different Lakehouse and then execute the script to generate the date dimension, and then you can simulate to bring the dimension here with OneLake shortcut. So okay, so if I've already built the COVID solution with the help of my free course, maybe you can bring it in directly, but I'll make sure to share the script to generate this dimension in case if you wanted to create this dimension directly, if without leveraging the shortcut as well. Or you can even simulate, as I mentioned, you can create a different Lakehouse and create the dimension there, and then bring that dimension as a OneLake shortcut within this Lakehouse, CareOps Lakehouse. That's totally possible. You can do it. So I'll share the script in the lesson below so that you can copy the script and then leverage it further and keep it ready. Okay, so it will have all the required date dimensional attributes that you would want: year, quarter, month, day of the month, day of week, week of year, and day name. So everything will be there. And I think in the script you can simulate the range, the timeline that you want in the date dimension. That you can always tweak and generate the data set for the date dimension. Okay, so that's all for this video. I think we are coming to an end for this particular module, transformations in the silver layer. And in the next video will be kickstarting module 5, where we'll be building the gold layer, fact layer. So it is going to be a patient level fact table that we're going to build, and then we will also calculate key operational metrics such as total dimensions, discharges, active admissions, average length of stay, then readmission gap and readmission flag, and the resource utilization. So there are quite a lot of metrics that we need to calculate, but we will first look at building the patient level fact table, and then we can look at the calculation of key operational metrics. So I think we will pre-calculate some of the metrics in the table itself, and then I think we will also look at how you can leverage DAX expressions, data analysis expressions, DAX, to create some of the measures right within the data model after building the semantic model itself. Okay, and maybe we can touch up a bit on what are the advantages of pre-calculating, or what are the problems or challenges if you pre-calculate, and what are the benefits if you calculate a measure using the DAX measure, and what are the cons. So I think we'll quickly run through that. Okay, so probably have a document. Maybe we can discuss about the advantages and disadvantages of both the approaches, pre-calculating the metrics or creating the measures using the DAX expressions within the data model. Okay, so we'll talk about it in another video, but we will kickstart the module 5 in the next video. So I'll see you in the next one. Thank you. Hi and welcome back. So we are in module 5, building our gold layer fact table, the patient level fact table. So we name it as fact patient admission. So it is at the patient admission level grain. So if you remember, we had to produce the admission discharge silver table, and for every patient we may have multiple admissions possible, and we generated the bed allocation kind of referencing the admissions for every patient. So if there are multiple admissions, we should have one bed allocation record referencing the admission for that patient. So that's how we built the logic, and then we loaded the tables. Now we are going to load the keys into the fact table, and we'll see how are we going to perform those required joins and then load the fact table, which is going to be at the patient admission level green fact table. Okay, and then we will also quickly look at how we can generate some operational metrics at the time of fact loading, and finally we will quickly validate using SQL queries. We'll probably look at few patient samples and see if the SKs are correctly getting loaded in the fact table, and if the operational metrics like the average, the length of the stay, and the readmission gap, and other metrics, if those are correctly calculated or not. So let me move on to Fabric real quickly. So here I am inside the workspace, and I've loaded the FactPatientAdmissions. So if I'll share the script below this lesson, so we'll quickly run through the script. So I think this is going to be the last PySpark script, I would say. So once we are done with the fact loading, then we'll move on to the data movement seamlessly from Lakehouse to Fabric SQL DB using data flows, and then we will look at how we can build the semantic model for reporting purposes. So let's quickly go through this script. So I'm importing the datetime PySpark SQL session, and make sure you import the import all the functions as aliasing it as F from PySpark SQL, and we are using the importing the window from PySpark SQL as well. Okay, and then let's initialize the Spark session. You name it as load fact patient admissions, and we are getting today's date using datetime dot date today and keeping it ready. And in this block of code, what we are trying to do is we are going to read the admission discharge silver data, which is cleaned and transformed. That should be our first step, to read the admission discharge silver table using Spark read format delta dot table, the table name, and then store it in data frame. And yeah, so as and when we read this, we can compute some metrics and then store it as a pre-calculated value in the table itself. So let's say I wanted to calculate the length of the stay, and in case if the discharge date for the patient is null, we are going to use today for calculation. So using with column, we are creating a column in this data frame length of stay, and we are leveraging the function, all the functions within the PySpark SQL. For example, when we are checking if the discharge date is null or not. If it is not null, we are using dateDiff function, and we are passing the call function and then passing the discharge date and admission date. So it's basically the difference, as simple as that. We are calculating the length of the stay between discharge date and admission date for any patient, and in case if it is null, the discharge date is null, we are calculating the length of the stay between today's date and admission date. So as simple as that, and that will get us the length of the stay for a particular patient record. And moving on, here we are trying to calculate the readmission metrics using a window function. Okay, so for any patient, if they have multiple admissions, so we wanted to calculate the readmission gap. Okay, so you can say readmission gap for that particular patient. So how can we calculate such metric? So you can use the window function that we have imported already, window library, and you can partition it by patient ID, and then keep the window spec ready first. Partitioning by patient ID and order it by admission date. So that's our window spec, and then using with column, we are going to calculate the previous discharge date using the lag function. Okay, so what lag will do? If we say lag of discharge date over the window spec, which is partition by partition patient ID and then the ordering it by admission date. So it will first order it, and I know it will partition and order it, and then when we say lag of discharge date, that will get me the previous discharge date for that particular patient and then store it. Okay, so as a prerequisite, we would require the previous discharge date that we're calculating, so that we can calculate the readmission gap correctly, right? So here we are again trying to check if the previous discharge date is null or not. If it is not null, we are using the date difference function to calculate the readmission gap between the admission date and the previous discharge date. Okay, so that will get us the readmission gap for any patient. Otherwise, we are keeping it as none. So that should correctly produce the readmission gap. We will validate once the fact table is loaded. And I think we are also trying to calculate the readmission flag. How are we doing that? So when the readmission gap is not null, and I think we are setting a limit. So maybe you can tweak and leverage and play around with this, because I'm giving the readmission gap, if it is less than or equal to 30 days, then I'm keeping the readmission flag as 1. But that, just to simulate or mimic the real world scenario, but it could be more than 30 days as well, right? A patient could be readmitted even after 30 days or 2 months, but I think just for simulation purposes for this POC, I'm just giving it as 30. Maybe in the fact table, you may see the readmission gap greater than 30 and the flag is probably not set there. But I think you can tweak and play around with this to mimic the real world situation. Average readmission gap for any patient probably in a real world setting could be around a month or 2. Just to mimic that, I set it as 30, but you can always play around and then look at the data. Okay, so we are keeping it as 30 just for demonstration purposes, and then we are setting the readmission flag. So don't probably know, in case in the fact table, if the readmission gap is greater than 30 days for a patient, you may not see the flag. So I think, so don't worry about it. Maybe you can play around with this per limit that I'm setting, and then you can look at your fact table. Okay, and let's move on. So we are trying to derive the date keys for admission and discharge using the date itself. We're just going to say admission date key and discharge date key, and that will come from the date itself. The key is going to be the date itself. Okay, so straightforward. And we are trying to read the silver patient dimension, and what we are trying to do here is we are going to filter to only the current patient record. So if you remember, we talked about in detail, when we were implementing the surrogate key. If you remember in the previous videos, the idea of implementing surrogate key is to kind of surface only the latest position, or for the reporting purposes. So at any point in time, even for historical data in the reporting, we should always reference the latest snapshot for the customer. And I think when you are loading the data into fact table and taking it to the model, you need to make sure you are always extracting the latest position or latest snapshot of the patient. And that's why we are reading only the current records from the patient info silver table, and I'm selecting patient ID and the patient surrogate key. So that's all I need in this data frame. Okay, so this is very important in case if you're extracting the complete data without keeping a filter, and then it would create problems in the fact table. Okay, so make sure you always extract the latest snapshot for the patient from silver table and then extract the data into the data frame. Okay, so that is very important. And we are aggregating the resource allocation data. So all we are trying to do is from resource allocation table, we are just going to group it by patient ID and then aggregating the count. That's it. So that will give me the count of resources for any patient, and then we are storing it in a resource aggregation data frame. So now what we're trying to do is we are also going to read the bed allocation data from silver table. It is not the silver, it is a single table that we're looking at, and we are fetching the patient ID, bed ID, ward key and admission date and storing it from that. So I think if you remember again, the bed allocation records, it's going to be referencing the admission record for every patient. And now I think we are trying to perform the join between the admission data frame that we initially built, ADM data frame, and then the patient data frame, and then the resource aggregation data frame. So we are doing a couple of joins to the patient data frame on patient ID, and we are doing a left join from the admission data frame to the patient data frame to make sure we are because the grain is going to be at the admission level, as I mentioned, right? So we need to capture every single admission record for the patient. Okay, and we are joining on the basis of patient ID. Okay, and resource aggregation data frame, we are joining again on the patient ID, and we are doing a left join. Okay, so the fact data frame is now loaded, and now again we need to perform the join with the bed allocation data. Okay, so the fact data frame, so we are joining with the bed allocation data frame. Okay, we are aliasing it, and we are going to join on the basis of patient ID, what key, and then the admission date, and make sure the bed allocation admission date falls within the admission window for the patient. So that is very critical, because the bed allocation record we are creating to make sure we are referencing the patient admission record. So if there are multiple admissions for any patient, we may have more than one bed allocation record, right? So when you're performing the join, we cannot do it only on the basis of patient ID. It will go wrong. It will create problems. So you need to make sure the bed allocation admission date falls within the range for that particular patient admission. Okay, so the fact admission date and fact discharge date. Okay, so it falls within that range. That's why we are also making sure the join is also happening based on the bed admission date, if it is falling within the admission window. Okay, so that is very important. Otherwise, you might run into issues in the fact table for sure. And we are joining on the basis of left join between the fact data frame that we built so far and then the bed allocation data frame. Okay, so I hope it's clear till now, and keep building. So we keep on adding, keep on joining to required tables like bed allocation, patient dimension, resource allocation, and then keep on building the fact data frame. Moving on, in case, I think here what we're doing is, in case of multiple bed allocations match, okay, select the one with the earliest bed allocation admission date. So that's what we are trying to handle here. So the window spec is defined, partitioning it by fact admission ID and ordering it by bed admission date. Okay, so I think this is an extra check that we are doing. I don't think there will be multiple bed allocation match, right? So we already validated using SQL queries. There must be one valid bed allocation for a particular patient admission. Even if there are multiple admissions for a patient, you will have multiple bed allocation records. And we are also making sure to join the bed allocation admission date, checking if it falls within the admission window or not. But I think you can also run through this in case, if there are multiple bed allocations match. Even after this condition, we are going to select the one with the earliest bed allocation admission date. Okay, so window spec is defined based on the admission ID and ordering it by bed admission date, and then we are using with column, we are using row number function. Okay, and we are trying to iterate through the window spec, and then we are filtering the top record with the row number that is equal to 1, and then we are dropping that column. And then what we are doing here is we are having the bed key, which is going to be the bed ID from the bed allocation table, and we are dropping the unwanted columns like the bed ID, admission date, and what key. Okay, so that's what we need. And moving on, we are calculating the resource utilization rate. So what does that mean? I think we are we already calculated the resource allocation count somewhere here, right? The resource allocation count. So we are just going to look at the rate, the resource utilization rate, by creating that column resource utilization rate. And here we are using lit function. We are giving a constant value. Let's say that is a constant number that I'm giving, which is 10. Okay, so I'm just trying to look at the resource utilization rate for patient. Okay, so and I'm keeping it as the upper bound is 10, which is what I'm giving by a constant value, and then you can calculate the resource utilization rate accordingly. Okay, so moving on, we are just adding a created timestamp. That's it, and then we're trying to finalize the columns for the fact table design. So that will have my admission ID, patient SK. We are aliasing it as patient key, so it is going to be the stable surrogate key from patient silver dimension table. then admission date key, discharge date key for that patient, then the ward key, bed key, resource allocation count for that patient. Okay, and we are also calculating the resource utilization rate for that patient, length of the stay, readmission gap and flag, and then the creator timestamp. So that's our final fact data frame, fact schema you can call, and it is at the patient admission level grain that we are building this fact table. Okay, so I hope it's clear till now. And then finally we are storing it as fact patient dimension fact table, and we are creating it as a delta table, okay, by overwriting with the mode override. So once you run through the script, I'll share the script in the lesson. So once you're done with the execution, you can come back to the Lakehouse and have a look at the preview of the fact patient dimensions. So we'll run some queries to validate the fact table quickly, and we'll look at few random patient samples and see if the SKs are correctly loaded and the metrics are correctly calculated. So you can see the fact table is loaded with the patient key, admission ID, then admission discharge dates, and if you are not seeing discharge date, maybe the patient is still active, and the resource allocation count, length of stay, and all the metrics that we have created, okay, calculated and then stored. So maybe let me move on to the SQL Analytics endpoint to run few queries to validate the data. Okay, fact table checks. So here I have a query. So what I'm trying to do here is I'm creating a CTE multi admissions as I'm extracting the patient key and then the count as admission count from fact patient admissions. We are grouping it by patient and then having the count greater than 1. So which means like we are trying to pull the multi admission for a patient in the CTE. And then in this query, what we're trying to do is we are joining the fact patient admission with multi admissions on the basis of patient key, and we are ordering it by patient key and admission date key. Okay, so let us look at it real quickly. You have to run these queries together since we are having a CTE here. So let it come up. So we'll look at few samples. So maybe look at third and fourth record. So we have the admission ID for a particular patient, and you can see the surrogate key is correctly loaded. For a particular patient, he has multiple admissions here. You can see different admission ID for that patient, but the surrogate key is correctly loaded. It should be same, so that when in the data model, when we perform the join to the patient dimension on the basis of surrogate key, you will always extract the latest snapshot for that patient. So that's the idea of implementing the surrogate key for the patient. And here you can see the admission discharge date. The patient got admitted on 11th of March and then discharged by 25th of March, and then he got readmitted on 4th of April, and it seems like he's still active. He's an active patient at the moment in a different ward. Okay, and you can see the bed key is allocated correctly. So we are looking at two different bed allocations, right? So the patient got discharged and the bed is probably closed, the allocation is closed, and then a new bed ID is bed key is allocated for the readmission, you can say. And the resource allocation count and the length of the stay, you can see it is correctly calculated. The patient, let's look at only 3 and 4 records, so that we can validate. Okay, so if the patient is not discharged it when he got readmitted, so we are going to calculate the length of the stay from admission date to today's date. So I think at the time of recording it is 23rd of April, but I think the script got executed back in time, on 5th, I guess. So that's why you are seeing the length of the stay as 1. But when you execute the script, so you may see a different metric, but you need to make sure it is correctly calculated. Okay, so don't worry about it. And if we move on, I think you can see the readmission flag is 1, and the readmission gap, this is the readmission gap that we're looking at for that patient, is around 10 days, which is right. So he got discharged on 25th of March and then he got readmitted on 4th April, so which is close to 10 days, right? So the readmission gap is 10 days, so which is correctly calculated, that we can see, and the readmission flag is also correctly tagged as 1. And the resource allocation rate, so we are looking at the rate as I mentioned. So the resource allocation the count is 1, so the rate is 0.1 because we are having a constant number there, 10 for every patient. So that's fine. When we look at the charts, we'll get more idea about it. And then the created timestamp. So as you can see, it is loaded on 5th of April. That's why you're seeing the length of the stay for the active patient as 1. Okay. So I think it's looking good to me. So maybe you need to validate your fact table data set, maybe looking at few patient samples and see if the admission ID, bed keys, ward keys, and if the metrics are correctly calculated, so that we are good to go for the next stage, which is our semantic model. So I hope it's clear to you. If you have any questions in loading the fact table, feel free to post in the comments below the lesson, so I'll be able to assist you further. So thank you for watching, and I'll see you in the next one. Hi and welcome back. So we are in module 6, data movement and semantic modeling. In this module, we will in the first video we'll quickly look at how we can seamlessly move the data from your Lakehouse to your Fabric SQL DB, which is in preview. So we will quickly create, we have already built some data flows Gen 2, but I will quickly let you know how you can create one, and it's just the kind of a copy activity that you're going to seamlessly move the data from Lakehouse to the Fabric SQL DB, right? And once we have all the tables loaded with the help of data flows Gen 2, then we will try and create some views on top of the tables in the SQL Analytics endpoint in Fabric SQL DB, and then we'll try to build the semantic model with the relationships between fact and dimensions on top of the views. And when you build your semantic model on top of views from SQL DB from its SQL Analytics endpoint, there is a warning that is displayed, so we will quickly talk about it. So when you're building a direct lake semantic model, I hope by now you're very much aware about direct lake semantic model, and there are 3 different storage modes that you can look at. So if you're not aware about it, I would recommend you to watch my free course, and probably I can share the link probably in the lesson below, so that you can look at it in detail. What are the 3 different storage modes that we have when you're building semantic model? And so when you're building a direct lake semantic model on top of views from Fabric SQL DB, and it may not work in direct lake mode as such, but I think we will talk in detail about it. It will try to switch to the direct query mode, right? So there is a warning. It says that it may not work with direct lake mode every time when you're building your model on top of views from SQL DB. So it may even switch back to the direct query mode. So I will show you that warning, and then probably you must be aware about it as well. Okay, but for the demonstration purposes, we are going to stick to the views for building our semantic model, and then we'll also, it's an opportunity to look at the warning, what happens when you're trying to build the semantic model on top of your views. So when you're trying to execute the report in a direct lake setting, I think it will directly send the query to the underlying source. Okay, but when you're building on top of view, it may not be the case, but I think we will talk more about it in detail. Maybe if you're not aware of those 3 storage modes, I would recommend you to watch that particular video in my free course to get a clear idea about what are those 3 different storage modes when you're building the semantic model. So direct query or import mode or direct lake mode. So direct lake mode is the efficient way to avoid any data duplication, and then talk to the underlying source directly when you're trying to generate your reports and then try to render your reports. So I'll share the link probably in the next video when we talk about semantic model, but I just wanted to give you a heads up so that you might be aware of what's coming up, right? So let's get started. In this video we are going to look at the data movement from Lakehouse to SQL DB. Okay, let me move on to Fabric portal real quickly. So here we are inside the workspace, Healthcare Operational Analytics. So I think by this point we talked a bit about the master pipeline. So by now we have the complete master pipeline ready, because all the scripts we have executed. So maybe you can build one if you want. a couple of invoke pipeline activities for patient dimension pipeline. So that has the bronze initial load, silver initial load, patient incremental load, and SK update. So we looked at each and every script. It is all notebooks, so you can chain those and prepare a pipeline if you want for the patient dimension and keep it ready. Okay, so it is a notebook activity. And in the CareOps master pipeline, we are calling using invoke pipeline activity, which is in preview. You can call that patient dimension pipeline as a first activity, and you can chain the activities here. You know, our patient dimension load should be the first activity that we need to establish, because everything else references the patient keys, right? So you have to make sure that is in order, okay, or in the sequence. But then comes the patient admission discharge invoke pipeline activity that will call the patient admission discharge, that has bronze and silver transformation notebooks. Okay, so coming back to here, so and then you can run your bed allocation and then the resource allocation script. So there are no sequence here as such, but you can link those, and then finally we are building our fact table notebook. So that's the order, or the master pipeline you can call it, for your CareOps Healthcare Operational Analytics pipeline that you can build with the required notebooks attached and then the pipeline invoked. Okay, so you can build one, and if you have any challenges, please let me know. And then you can also try and delete all the tables loaded in Lakehouse, and then you can for simulation purposes you can delete all the tables. At the time of executing your notebooks, you may have created the table, but to simulate the pipeline end to end, you can delete all the tables in Lakehouse and then try to run this pipeline end to end. Okay, you can run it or even schedule it. Okay, and once it is done with the execution, you can verify if all of the tables are created successfully, including the fact table and all the dimension tables. Okay, I think dimension tables are not part of here. You have to execute it separately, the dim ward and dim date. But I think we have patient dimension and the other required tables created with the fact table created finally. Okay, so that's one thing I wanted to show you, so that you can have a pipeline, master pipeline, chaining all the activities to create that fact table, okay, in the Lakehouse. So now you have, at this point, you should have all the tables in your Lakehouse, in CareOps Lakehouse, including your bronze, silver tables, dimensions, fact table, patient info, silver, okay, and patient info, bronze, and resource allocation. So these are the list of tables that we are looking at for our complete POC. So now the idea here is to move all these tables seamlessly to your Fabric SQL DB. Okay, so at this point, if you're just having Lakehouse, you can go to your workspace and create a new Fabric SQL database which is in preview. Okay, and name it and keep it ready. And then once you're having that database ready, you can come here, and I have set of data flows created for every table. Okay, so I'll quickly showcase, probably what we are doing here. It is very simple. It's similar to a copy data activity without any transformation, okay, from Lakehouse to Fabric SQL DB. But we'll quickly look at one, and then maybe I can also show you how we can build one data flows Gen 2 to copy the data seamlessly from your Lakehouse to Fabric SQL DB. Okay, so if I open the data flow admission discharge, it is a Power Query experience. So data flows Gen 2 is a Power Query experience. Okay, so you'll have a view like this, and all the applied steps are here, and the data destination is here. So maybe I think you may probably want to start with this. So let me show you how you can do that. So every time when you're trying to navigate, it will ask you to close this data flow. So let me close this, and if there are changes, it will prompt. So nothing. So let me try to create one new data flow Gen 2, so that you can follow along to seamlessly move your tables. So let me create one. I'll keep it as data flow 1 only. Let it come up, and this is the wizard you will get, to bring the data into your data flow Gen 2. So you should say, maybe you can say, I wanted to get the data from another source, from my Lakehouse, right? So we are going to move the data from Lakehouse to Fabric SQL DB, which is our destination. So here I'm not looking at any other source. So I can directly go to OneLake. Okay, so I wanted to bring the data internally, right? So internally from within the OneLake, I wanted to move the data from my Lakehouse, CareOps Lakehouse to CareOps DB, right? That's it. So I'm looking at OneLake catalog, and here I have the CareOps Lakehouse. I just wanted to connect to it by clicking on it. So once you're connected to Lakehouse, you can see all the tables that we have here in the Lakehouse. So let's say I wanted to move this admission discharge silver table, okay, to my SQL DB. And whatever tables you wanted to move, you can select everything in one single go. But I think I have created, different data flows. Single data flow for each table. You may not want to do that. You can select all of the tables that you want to move in one single go, and then you can load it into the SQL DB, right? So you can try that, because I wanted to kind of write the table into the SQL DB with the schema what we have here. So I'm not creating a schema separately in SQL DB and then syncing the data. So at the time of loading, it will automatically fetch the schema from Lakehouse and then write it to the SQL DB and define the schema there. But that's why I wanted to break it in chunks and then having data flow for every single table. Maybe you can follow along with the same single data flow for every single table. Okay, so that is easy to probably run it and execute it, and then if there are any issues, it's easy for you to troubleshoot instead of selecting all the tables. Okay, let's say I wanted to move the fact table. Okay, let's say that. Click on it and then say create. So you can see it's loaded. Okay, so here you can see some of the applied steps that we applied, and at the bottom right you can see there is a data destination. So that's the one that you need to configure, and you can see different destination options, and we wanted to move the data to SQL database. So click on SQL database, which is in beta, that you can see, and connection credentials. You may probably want to create a new connection if you are doing it for the first time. Okay, so do that and establish the connection with your organizational account. If you have a trial up and running, so it will be easy to set up one connection, and click on next, and it will show you all the different SQL databases, okay, that you have, including the SQL Analytics endpoint. So but we are interested in healthcare operational analytics, and we have this CareOps DB that we have already created. Okay, so I think it will already list all the tables there. I've already moved it. Okay, so that's why you can see all of those tables already loaded in DB. But you can choose the container CareOps DB, and then that should be your destination target, and make sure we are going to create it as a new table, okay, in the destination. Okay, so if you're choosing existing table, you need to have the schema ready in your SQL DB destination. Otherwise, if you say new table, it will automatically create that table for you in the SQL DB. So that's what you need to do, and then click on next, and it will be done with the destination definition. Then I think that's all you need to. We are not doing any transformation as such here. So we are trying to seamlessly move the data from Lakehouse to our SQL DB destination. So that's all we are doing. So let me close this. In case if you have any challenges in moving the data, please let me know. Let me discard this. Okay, so now coming back to, let's say, take any data flow. So that's all we are doing. We are trying to define the source, and then we are trying to navigate to that table, and then we are defining the data destination and syncing it as a new table. So set up all those data flows for your table. Okay, so different data flows for all the tables that you need to seamlessly move it to our SQL DB. So once you're done with that, you should have all the tables loaded into your SQL DB. Okay, so for our next step, which is our semantic modeling. So if I go back to the workspace, so let me go to CareOps SQL DB. We open the SQL DB, which is in preview. So execute the data flow gen 2 for all the tables, and you should see the table loaded successfully in our CareOps DB here. Okay, so under DBO schema, so you should see all the tables loaded here. Admission discharge, silver has been loaded here. Bed allocation, dim date, dim what, fact patient admissions, patient info, I'm not naming it as silver, so you can change the name in the destination. So we don't want to mention it as silver and medallion architecture here. So these are the final tables which you're going to build the semantic model upon, right? So resource allocation. So that's all loaded. So once you have all the tables loaded in SQL DB using data flows gen 2 to seamlessly move the data from your Lakehouse to the SQL DB, then we are ready to build our semantic model. So in the next video, we'll quickly look at the SQL Analytics endpoint. So if you remember, during the start of this course, I mentioned some of the advantages of SQL DB, Fabric SQL DB especially, which is in preview. So it automatically replicates the data to OneLake, using the SQL Analytics endpoint. Okay, so that you can start querying your data, and even I think building semantic model on top of the views have some challenges. We'll talk about it when we are building it. But we are going to build on top of view so that we have that opportunity to discuss about the 3 different modes I was talking about, the import modes, the storage modes in fact, and we have import mode, direct query and direct lake. And when you're building semantic model with direct lake storage mode on top of SQL views, we have a challenge. Okay, we'll talk about it when we're building the semantic model. So the main advantage of Fabric SQL DB, it automatically replicates the data to OneLake, and it is ready for you to consume that data for all the downstream processes. You can use Spark or any analytical engine to analyze the data further. Okay, so it will be automatically replicated. So we spoke a bit about it during the start of the course. So I just wanted to remind you so that you can keep that in mind. One of the advantages of using Fabric SQL database. Okay, so I'll see you in the next one. Hi and welcome back. So we are in module 6. We just looked at the data movement from Lakehouse to our SQL DB, which is in preview edition. And then now in this video, we are going to create our semantic model from fact and dimension tables. Actually, it's views in Fabric SQL DB. We'll quickly look at how we can do that. What are some of the challenges that we're facing, that we're going to face in case if you're building our semantic model on top of the view. But Fabric is not restricting you to build the semantic model on top of views. You can still do that, but there is a catch which we will talk about it in this module, okay, in this particular video. So let me move on to Fabric real quick. So here we are inside the SQL DB. We just saw all the tables are moved and we have the tables ready in our DBO schema. Okay, now let me switch to the SQL Analytics endpoint. On the top right, you can switch to the SQL Analytics endpoint from SQL DB. That will take you to the Analytics endpoint. Okay, so here you can see it's switched, and you can see all the tables here for further querying. And you can also see I have created some of the views for every table. We will quickly go through that. Okay, so you may have a question at this point. Why are we not picking up the tables? Why we are creating views for our semantic modeling, right? So that's a valid question, but I'll tell you why. So let's take this patient info view. So there are a lot of views we have created. So we'll go through one by one. If you just right click this view and click on this 3 dots. Let's say I wanted to alter this view so that you can see the script for the view. So these views are straightforward. We're just pulling the data out of the respective table from DB. Okay, but with respect to patient info, let me just quickly open the script, alter script for the patient info view. So there is a catch here. I'm pulling only the current records from the patient info table. Why we are doing that? So if you recall, we are going to surface only the latest patient snapshot to the data model, right? So even if you remember, during a fact building, we were joining with the patient info silver table on top of the current records, only the current records. Okay, so we have it as a CD type 2, and I think when we're loading the data to fact table, or when we are building the semantic model we need to make sure we are surfacing the current record for the patient, the active snapshot or the latest snapshot for the patient. That's the reason we are creating views, because the patient info table, if you surface it and then try to perform the join in semantic model, I think it will create problems. So you may not want to do that. You have the records already loaded. I mean, the facts are already loaded, okay, by referencing the latest. I mean, it will still pick the surrogate key, as I told you, when we are loading the fact table. It will try to join with the current record and then pick the SK. If you're not joining to the dimension during your fact load on top of the current record, it will have multiple records for any patient and it will create join problems, right? So you may run into issues for sure. So you need to be very careful at the time of joining during fact loading. You need to reference the current record in the patient dimension, and also when you are building your semantic model and when you are loading your patient dimension for relationships definition, you need to make sure you are pulling only the current record from the patient dimension. That's very important, otherwise you may run into issues for sure. So please make a note of it. That's the reason we are creating views for all. Maybe other tables may have a straightforward select, but for patient we are having the filter is current is equal to 1, and then we are altering it as, we are producing a view patient info. So that's the idea. And I think maybe once we talk about that warning, so maybe I think you may want to build your semantic model in import mode. So when we say import mode, I hope by now you have some understanding by looking into the video that I talked about in detail in my free course, or you can even Google out about 3 different storage modes. So import mode basically duplicates the data in your model, semantic model. It will be in the memory, right? So from the underlying source, it will create a copy. Okay, it will duplicate the data in your model in memory. But direct lake, as I mentioned, it is a direct. It will directly talk to the underlying source without any duplication of data. So that's the advantage. And direct queries, again, it will talk directly to the underlying source, but the problem is it will be very slow. But direct lake is much faster and efficient. Okay, so those are the 3 different modes in brief. But when you're creating your semantic model on top of view, you'll try to create a direct lake model, but it will end up throwing you a warning saying that it may not work in a direct lake mode always. Okay, so we'll look at that so that we'll get some clarity. So once you have the views created, right, so you need to come to reporting. So make sure you are in SQL Analytics endpoint view. Okay, because in database view you may not see the reporting tab, I guess. You may not have those. So you'll have replication security tabs, but you may not have the reporting tab. So switch to SQL Analytics endpoint. Okay, and navigate to reporting. You can see you can create a new report, new model. There is a default model generated for you, but don't worry about the default semantic model. We are going to create a new semantic model. So the model is already built, but for demonstration purposes, let me show you what you need to do if you need to create the model for the first time, right? So click on new semantic model. It pops up a window. It says clearly it is going to be a direct lake semantic model. As I mentioned, the semantic model will be created in the chosen workspace in direct lake storage mode format. So that's the important thing that you need to note. Okay, it says direct lake when you create the model. Okay, and you can enter the model name as you want, CareOps model or whatever name you want, and we are inside this workspace, and you can see you can start selecting the tables or views. Okay, so if you just scroll down tables, so you can see all the tables are listed and also the views. So Microsoft is still providing you the capability to build your semantic model on top of views. Now, that's exactly what we did in this POC. We are not building on top of the tables. That will run into a problem. So we need a view with the latest position for the patient, right? So that's the idea. So select all the views, okay, and then you can confirm, and then it will load. It will take you to a modeling window, Okay, and then you can start building the relationships, but I'm not going to create it, so it is already built. But in case if you have any challenges when you are trying to create a new model on top of views, let me know in the comments so that I can check that further. Let me cancel this and let me come to workspace. Let me open the model which is already built, CareOps model, so which is inside this workspace. So let me open that model. So you need to say open the data model. Model window is open for us in a view mode, so you can go to edit mode and make any changes. But okay, so those are the two views you can switch. So you can see it is already okay. So it says you are in viewing mode, changes will not be saved. So you can see already I've established the definition. So we'll quickly look at the relationships we have established between the fact and the respective dimensions. But on the right side you can see the list of tables, which is actually the view that we are importing, and the model options you can have. Okay, like the measures and cultures and other information. Okay, so under tables, I told you about the warning, right? So you can see here there is an exclamation mark next to the views. So what is that? Let me mouse over. You can see it says the DAX queries when you generate the report may fall back to direct query mode if allowed, or show errors. To fix this, try refreshing the semantic model, scaling up the capacity, or avoid using SQL endpoint items like views. So that's the catch. So it says, it may fall back to direct query, even though it is a direct lake semantic model, which will talk to the underlying source without copying the data. Even in direct query mode, it won't copy the data, it won't duplicate the data, but it will be much slower compared to direct lake mode. Okay, so you can read more about it, or you can watch my video. It is available in the free course. So Microsoft is providing that warning, it may fall back to direct query from direct lake. So stop or avoid using endpoint items like views. So maybe I think Microsoft is working on it to improve. I'm not sure, but right now this is at the time of recording, this is the case. They are producing this warning and asking us to avoid building the semantic model on top of views. Okay, so you can see almost that warning for every view that we have here. So let's quickly look at the relationships. Let me minimize this. Okay, so here we have our fact table, and we have some of the measures. We will look at it shortly that we are building within the data model. So we will also talk about the advantages and disadvantages of building the measures right within the data model using DAX expressions, and what are the pros and cons of pre-calculating in the table itself. Because if you remember, we have already pre-calculated some of the measures like length of stay, readmission gap, flag, and all those things, and we are also calculating some measures that you can see here. So that we will discuss in detail. Okay, so but we'll quickly look at the relationships and wrap up this video. Okay, so on the right side, click on data model. So let me minimize. So relationships, you can see here. Expand the relationships, it will be easy so that you can define. So okay, so you can see all the relationships here, but I want you to establish the relationship for each and every dimension. Let's say so here we are establishing it to, so let's say this is to bed allocation. You can double click. Let me click on it. Okay, so it's in viewing mode, that's the problem. So let me switch it to editing mode. Click on the relationship. So you can see it opens the relationship between fact and the bed allocation, and that's on the basis of bed key to bed ID. Okay, from many to one, from fact table to the dimension. So your cardinality should always be many to one from fact table to your dimension table, and this relationship is active with the cross filter direction as single. Okay, so almost it's same for every other dimension. If you look at to date dimension to admission discharge, we are linking admission ID to admission ID, on the and the cardinality is many to one. Okay, so try establishing the connection. Okay, so now what other relationships that we need? So we need to link to the date dimension. So here I think we are going to, let me move a bit. So here I think you can see we are establishing connection between admission date key and date. See, since our analysis is going to be based out of patient admissions, so even all of the reports that we are going to generate, the time-based analysis is going to be based on the patient admissions. So that's why we are linking the admission date key to the date. So let me open that. You can see between fact and date, we have linked the admission date key to the date attribute as many to one, and this relationship is active. So our analysis is going to be completely based on the admission date, okay, for a patient. So keep that in mind, and I think you can establish the relationship and keep it ready. And also the patient info, the patient dimension, we are linking. Okay, this is for ward, between fact and ward. We are linking from what key to what key, right? And that is done. And then the patient link is here. So between fact and patient info, we are linking on the basis of surrogate key, right? So which is our patient key, if you remember. So we are going to connect the fact to dimension on the basis of the patient SK in patient info table, and it is going to be the patient key on the fact table side, and it is going to be many to one. Okay, so I hope I have covered all the relationships. You can start establishing the connection, and in case if you're facing any challenges in establishing the connection, and then model this. So essentially we are trying to build a star schema here with fact and dimension relationships. Straightforward. Make sure you are correctly mentioning the cardinality and between the fact and dimension tables. Okay, I think to establish the relationships, it is quite straightforward. You can drag and drop a particular attribute that you want to establish the relationship. So maybe I can show you one. So let's say I wanted to establish the relation between fact table to the patient dimension. Where is our SK? Here is our patient key, and here is our surrogate key in dimension. Just drag this attribute and keep it to drop it to that particular attribute that you want to link in the dimension. It will open a new relationship window between the fact table to the dimension, and you can see it is correctly selected patient key to the patient SK. And you can see we have already defined the relationship. That's why you are getting a prompt. There is already a relationship between these two columns. So just wanted to showcase. So that's how you can start establishing the relationship by dragging and dropping the required key columns between fact and the dimension tables. So once you're done with the setup, then we are ready to go. We can start building our reports. So, but I think in the next video, we will quickly cover some of the measures that we are creating. There are quite a lot of measures we have created here in the fact table. So we'll quickly look at those, and we'll also talk about the pros and cons as I mentioned earlier. So I'll see you in the next one. Thank you. Hi and welcome back. So we are in final module, dashboarding and advanced reporting. So we will in this video we'll quickly look at using DAX expressions, data analysis expressions, to create some measures in our fact table in semantic model. I think we can calculate average length of the stay, occupancy rate, readmission metrics, and we will look at all those metrics and DAX expressions. And under this lesson I'll be sharing all of those DAX expressions as well, so that you can recreate those and prepare your data model further. And then in the next and final video we will look at how we can design some operational dashboards. So we will look at a few reports, and then the couple of dashboards that we'll be building, and then we will wrap up the course. And in the final module we will be having real world discussion and Q&A in case if you have any questions, any improvements that you think we can make to this course, or any updates that we can include in this POC. Feel free to discuss in that final module. So there'll be dedicated space for further discussion as well in that module. So let us move on to Fabric portal real quickly. So here we are in the semantic model, CareOps model. So I hope by this point you have established all the relationships between your fact and dimension tables. Okay, and what we will do in this video, we will in the fact view fact patient admissions. So I think one thing to quickly note, if you just scroll over to the blue dashed on top of every table, that suggests it's a direct lake. You can see the storage mode is direct lake, right? So but I think we have seen that warning. If you can recall, it will fall back to direct query as we are building our semantic model on top of our views. Okay, so having said that, let us quickly run through some of the DAX expressions we used to create some of the measures. We'll quickly go through all of those metrics. It's not quite complicated, it's straightforward. We'll quickly go through that, and if you think you can create more measures out of it, feel free to go ahead and create those measures using DAX expressions and build your model further. Okay, so just for demonstration purposes, I have created few measures here so that you can see with this icon. So these are table attributes and these are measures that we have created right within the data model. So let us look at one by one. We will go with the easier ones. The total admissions, we are just counting the rows in the entire table. Okay, because if you remember, this fact table is at the patient admission grain, right? So that you have to be very much clear about it. That's why we are looking at the count of rows from the fact table, and that will give me the total admissions. Okay, so that measure is quite easy. And for total discharges, so we are going to look at so we are going to count the rows and we are applying filters on top of the fact table. And what is that filter? We are using not operator and we are saying is blank the attribute discharge date key. Okay, so the discharge date key shouldn't be blank. Okay, so that means like the patient has got discharged already, and those are the records we wanted to count, and that will be measured as total discharges, as simple as that. And total readmissions, we are calculating the count of the entire rows in the fact table with the readmission flag is equal to 1. Okay, so that will give me the entire total readmissions as well. Okay, so those are simple measures that we are calculating. And then the readmission rate percentage, how are we calculating that? So we are having a couple of variables. The total admissions, we are calculating it and keeping it in this total admission variable, and readmission admissions, we are counting the rows and by applying the filter on top of the fact table with the readmission flag is equal to 1. So that will give me the total admissions and readmissions, and we are just going to just do a simple division between the readmissions to the total admissions, and we are calculating the percent. So that will get me the readmission percentage measure as well. Okay, and average length of stay, what we are trying to do here, it's we are using average x function, DAX function, and we are trying to calculate the average on length of the stay attribute, and that will get me the average length of the stay. Okay, so that's easy, I would say, quite easy. And average readmission gap, how are we calculating it? Average readmission gap in days for patients. So we're again using the average x function, and then we are using filter function. Okay, and we are passing the table, and then we are saying the readmission gap is not equal to blank. Okay, so the readmission gap shouldn't be blank. Okay, and then we are kind of calculating the average on top of the readmission gap, and it shouldn't be blank. Okay, so as simple as that, and that's how we are calculating the average readmission gap as well. Okay, and what else? Active admissions, how are we doing that? So we are using count of rows and then filter function, and we are using is blank DAX function, and we are looking at this attribute discharge date key, and if there are blank discharge date keys, that suggests the patient is still active and we wanted to look at the active admission as well. Okay, so that's why we are calculating this active admission measure by applying the filters and then counting the rows on top of the fact table. So I think all of those measures are pretty much straightforward and simple for our reporting purposes, but you can also think of any complex measures, and then you're welcome to create those in your data model, and then feel free to comment probably in the same lesson below with what you have come up with, and it will also help the entire community, you know, so that they can also leverage your thoughts as well. So there are always opportunities to improve the data model, so I'm just giving you few to kickstart so that you can build your own data model further and leverage it further for reporting. So those are the measures that we have built on top of the fact table in the model itself. So probably in the next quick video, I just wanted to quickly discuss the pros and cons, you know, as I promised. What are the advantages of creating this measures on top of the model, and what are the advantages and disadvantages of doing it or pre-calculating it in the table itself, because we have quite a few measures, you know. We can calculate the length of the stay right within the model, but we have already pre-calculated in the table. So we will talk about both of these approaches, you know, in the next video, in a quick 2 or 3 minute video. So that will help you to understand the differences. So I'll see you in the next one. Thank you. Hi and welcome back. So in this video, we'll quickly look at the advantages and disadvantages of pre-computing the metrics in the table and in the semantic model using DAX expression. So that's a very good opportunity for us to look at the pros and cons of both approaches. So here I have a document. I'll share this if you want. So let us quickly go through this. So it will give us a clear understanding on when to go for which approach. So the choice is completely dependent on several factors, you know. It depends on the use cases and the system architecture, I would say. But we will look at when, probably for which case you need to go for which approach. So the backend pre-computed metrics like the length of the stay and all, for example, for our POC, we have pre-computed already in the table. And the average length of the stay, we have used DAX expression and then we calculated. So we did a hybrid approach, I would say. We did some calculation in the backend, and then we did some calculation measures we built using DAX in the semantic model. So what are the pros when it comes to pre-computing in the backend? So calculating values like length of the stay in the backend means they're pre-computed and ready to be used as soon as the data is loaded in Power BI. Okay, so you don't want to run it on the fly again in Power BI. It can improve the report performance since it's already pre-computed for you, especially if the calculations are very much complex and it requires large data sets. Okay, and also reduced load on Power BI. By performing the calculations in the backend, you avoid putting extra overhead to the Power BI engine itself and at runtime, right? So which is quite beneficial for larger data sets, you know, if you're looking at. And consistency across multiple reports, in case if you require this across systems, you know, the calculations across systems, doing it in the backend ensures consistency and avoids any recalculation. So that are the pros, I would say. But what are the cons? Less flexibility. The problem is once the data is calculated and loaded in the backend table, in case if there are any change in the calculation logic, let's say, then you need to redo it. I mean, kind of reload the data and recalculate it, and it requires some processing time, you know. That can be time consuming as well, since you're looking at a reload of that particular metric in the backend table. And the data processing overhead as well, depending upon the size and frequency of your data set, performing the calculations in the backend can lead to higher compute costs because you're going to reload the data again, you know, and there could be delays as well. Okay, so those are the cons. But let us look at the DAX calculated columns in the measures in Power BI. So the pros with respect to calculating the measures using DAX in Power BI, it's dynamic and flexible. It allows you to make changes to your calculation without modifying your underlying data. So that is better. And this is quite useful if you need to test different calculations and adjust them frequently, right? So that will come in handy. And it's quite efficient for smaller data sets. If you're looking for larger data sets, it's always recommended, or you know, it's best to pre-compute. It is if your data set is quite smaller, like what we are looking at in our POC, then DAX is much efficient and can handle without any overhead. On-demand calculation, the calculations are done on the fly, meaning only the data in the current filter context is used. You know, this makes it more dynamic, you know, and responsive to user interactions on the report. What are the no extra backend work is required, and what are the cons? So performance issues. See, in case if you are looking at a larger data set, and when rendering the report, you may run into probably performance issues. So it could be resource intensive if the calculations are complex. That is one. And the dependence on Power BI. This calculation will only be available within the model. So if you need them in other tools and systems, then you have to replicate the logic what you have in the DAX, right? So that is one challenge as well. Okay, so if you need to have it in other tools and systems. So efficiency comparison, as I mentioned, for the large data set, you can go for pre-computation, and it offloads much of the processing from Power BI, and it makes your reports much faster. Smaller data set, you can go for DAX calculated columns. So you may argue this statement, but feel free to comment below if you think otherwise, and what are your approaches. How do you approach and decide how whether you wanted to calculate DAX measures or whether you will pre-compute it. So the recommendation probably from my side for scalability and performance, if you are looking at performance reports and if your data set is quite huge, then it's always good to pre-compute by defining the logic in the backend, and it will be readily available and it will be consistent if you have multiple consumers of the data. But for flexibility, and if you want to maintain it easily, then use DAX. If you need more flexibility in working with relatively smaller data sets, then it's much recommended to go for DAX. So those are my thoughts, I would say, and let me know in the comment section below, so that we can discuss further about your possible approaches. So thank you for watching, and I'll see you in the next one. And that will be our final video, where we will look at some of the reports that we are generating, and then a couple of dashboards. And you're always welcome to create your own reports out of the semantic model. There are always opportunities. You don't want to follow what I have been creating. So you can create your own reports, nice dashboards, and then you can share it with the community, so that everyone will be benefited. So thank you. I'll see you in the next one. Hi and welcome back. So we are in final video in this course, in module 7 final video, where we will quickly look at generating some of the reports and a couple of dashboards. And there are always opportunities for you to explore further and even come up with your own reports and dashboards. But let me quickly move on to Fabric portal. So here I'm in Fabric portal. So before we move on, I just wanted to show you a couple of other metrics that I missed to show you in the previous video. So if I go on to edit mode, under bed allocation, we have a couple of measures we created under bed allocation view. So I think one is occupied beds, where we are calculating the distinct count of bed ID, and then we are filtering by so we have the bed status there, right? So we are filtering it by the bed status occupied. Okay, and we are looking at a distinct count of bed IDs, and that will get us the occupied beds. And bed occupancy rate, I'm trying to divide it with a constant number. Here in this case, I'm just assuming the total beds are like 10,000 in the hospital, and I'm trying to calculate the bed occupancy rate. Okay, so with the occupied beds we already calculated, divided by the total beds that are available in the hospital, and that will get us the bed occupancy rate as well. Okay, just to quickly show you. So let us move on to the report, closing the model, and CareOps report. So quite a few reports I have created, so you can come up with your own reports, as the data model by now is ready. But we'll quickly go through some of the simple reports and then the dashboards that I built. So here in this report, we are looking at average length of the stay by ward name. Okay, so we have the ward dimension, and we have a metric average length of the stay. I wanted to look at the average length of the stay in every ward in the hospital, so then we can look at the metrics. So since we cooked up synthetic data, so you can see for ward B, the average length of the stay is close to 28 days, and 29 days, and ward C 26, and then ward D is again 26. So in a real world setting, it might differ, and it could be fluctuating, it could be fluctuating, but we can't see a significant number here. It won't work. So just for demonstration of with our synthetic data, so it falls within a month. So the average length of the stay for a patient, at least at the ward level. So you can see ward B and A is pretty much occupied. Maybe those wards, we can interpret or infer like those wards are handling complex cases compared to other wards, which are handling less complex case, you can say. So that are some of the inferences that you can derive based on this kind of report, and I think it's pretty much straightforward. So you need to pull the average length of the stay metric that we calculated from fact table, and I'm bringing in the ward name from the ward dimension. Okay, so and I'm building this simple report. Okay, so that's how we're building it, and let us move on. So here in this report, I'm looking at the total admissions, total discharges, and then the active admission by date, so which is like a time series, you can say, that total admissions, discharges, and active admissions based on time. I wanted to do a time-based analysis, and as I mentioned, it is the date that we're trying to pull here is linked to the admission. So now just to remind you again, the level of grain in fact table is at the patient admission level. Okay, and here I think we are bringing in the total admission discharges, and from the view date dimension, I'm bringing in the date into my x-axis. Okay, and I'm bringing the required metrics accordingly. Okay, so here what you can infer from this report, you can see there are the admission and discharges are fluctuating. So here the admission, you can see the light blue and dark blue is total discharges on every single day, and then the active admissions in orange. So since it's a synthetic data, I think it's pretty much kind of fluctuating, which is good. So across months, right from October, November, December, the last 6 months, the admission and the discharges and active admissions are kind of showing a fluctuating pattern that we can see. But if you remember, we were trying to simulate the seasonal flu kind of a scenario, right, on December and January with the monthly weights we have demonstrated. So that's why you can see around December. Okay, so the December, you can see there is a increasing trend, okay, till the month end, and then again in the January, you can see there is a kind of increasing trend compared to other months, right? So you can clearly see those spikes between December and January that we were trying to simulate kind of a seasonal outbreak in those 2 months. That you can clearly see the admission level spiked, and the discharges and the active admissions also you can see kind of a spike in those months that you can clearly see. Okay, so that kind of inference we can infer or interpret from this report, since we simulated that kind of scenario. But in a real world setting, this report can give you a lot of insights, I would say, by looking at a kind of a steep a spike kind of a pattern. So they can quickly look at why there is a spike in a particular month. Does that sounds like a kind of outbreak situation that hospital need to kind of come up with more resources, the beds or whatever it may be, staffs to take care of it. So that and you can clearly see so this report was generated, as I mentioned, during the first week of April. So I think when we were running those scripts, so I think we are seeing a significant spike here. We were trying to simulate the COVID kind of a scenario, as I mentioned in when we were running the script, right? So you can see there is a significant spike in total admissions and then active admissions, but there is the discharge levels were quite dropped. So this I wanted to simulate kind of a COVID kind of a scenario here, an outbreak situation. So hospital can look at this kind of report, and then they can take kind of actions they wanted to take, since we are seeing a significant spike in the total number of admissions, and there are less discharges, and the active admissions are keep on spiking, right? So since it's a synthetic data, we were trying to simulate when we were generating this report and running the scripts during the first week of April. And I think if you remember, we were providing the monthly caps, right? Monthly caps for every month, and for April also we were giving a significant, the equal proportion to maintain that distribution. We have given it for April also, and since the report was generated during the first week around 5th of April, and the cases the records were accumulated during the first week in April, and that's why you're seeing a significant spike in total admission and active admissions. And that's a good opportunity to kind of demonstrate an outbreak kind of scenario, I would say, like a COVID kind of scenario. During first week of April, we are seeing a significant spike in admissions, and we can infer kind of a outbreak situation. These are kind of seasonal trends that we are seeing, and there is a sudden spikes which kind of tells us there is a kind of outbreak situation in the hospital. Okay, so that you can infer from this kind of report, and feel free to comment, and you can come up with such reports, or you can always probably let us know how we can improvise this report for further inference. Let us move on. So here I think it's a simple report. We are looking at readmission rate percent by month, month on month. So what you can clearly see during April month, the readmission rate has been increased significantly, and then there is a drop. And I think we are looking at only 6 months, right? So that's why you are seeing a flat line here in those months. Since we are looking at it monthly level, and there is a spike in the 11th month. Okay, and significant spike in the April month. Okay, so that we're trying to demonstrate a outbreak kind of a scenario here. Okay, and move on. So this report I'm trying to look at, so in case if you want to look at the fields, how we want to generate a similar kind of report. So you can see bringing in date in x-axis, and then average readmission gap in days, okay, that I'm bringing in. So you can see it's a kind of fluctuating pattern again, and it ranges from kind of a low level to up to even 88 days during March 18th, which tells us the patient that so since it's a synthetic data, you can see such a kind of fluctuation here. But in a real world setting, the readmission gap days could be probably on an average, it could be 30 days or probably 25 days might be. But since it's a POC synthetic kind of data setting, so we are seeing max of 3 months, the patient readmission gap, average readmission gap for patients in days. Okay. So I think since it could be kind of skewed as well, if a single patient kind of returning after 2-3 months, and if the other patients in a particular day, kind of the readmission gap is low, and even a single entry could skew the average, right? So that's a kind of the synthetic data that we have produced, showing kind of a fluctuation pattern here with days ranging from as low as 4 days till 88 days. Okay, so that is the average readmission gap by date. And let's move on. So this report I'm trying to showcase the total readmissions and average readmission gap by ward, every ward. So we have 4 different wards in a hospital, and you can see the light blue bar is the total readmissions in that particular ward, and the average readmission gap in days in that particular ward. So we can clearly see the ward DNA have larger, more number of readmissions. So it suggests that those wards are kind of handling complex cases. Let's say we can assume that. Okay, so larger readmissions with larger gaps. Okay, so it suggests that the wards could be handling complicated cases, you can say, and they stayed out for a longer time, and then they returned. And probably with lesser, if you're seeing lesser lower readmissions with lower gaps, so it suggests that the ward might be having some follow-up programs, so that the readmissions are lower, let's say, compared to other wards. And if even the gap, if it's also lower, it means that in the readmission also happens sooner. Okay, so for that particular ward, the patients handled in those wards as well. So you can infer such a kind of report, maybe with the data that you're going to generate. Feel free to post in the comments the kind of report that you're generating and what you're trying to infer from those reports. Okay, so let's move on. I think this is one such important report, I wanted to let you know. So here we are looking at a patient level journey report, because here I have a slicer. Let me show you that quickly. So here I'm bringing in the readmission flag. Okay, so whatever attributes that I require, so I'm bringing in the from readmission flag and readmission gap from fact, but from patient info dimension, bringing all the required attributes like the patient name, gender, because I'm going to look at the patient level report here. So we can bring in the patient level information here. Okay, and what else is required? So here I'm having a slicer. Okay, so what I'm doing with that slicer, and from the admission discharge, I'm bringing in the admission date into the report, discharge date and length of the stay. So kind of I'm building a table kind of a view to look at a patient level journey. Okay, so and also I have a slicer here, as I mentioned. So this is the slicer that we have. So we are building the slicer with by bringing in the diagnosis and name from patient dimension. Okay, so if you just minimize this, so here I have, if you expand this, I have the diagnosis followed by the patient name also, so that I can filter or search for any particular patient and look at their look at the specific patient journey, the admission records as well. Okay, so maybe we can look at some samples. So maybe let me look at with the readmission flag 1, probably let's say April Hall. Okay, so I'm going to search that patient. Let us put it in view mode, it will be easy. Is it already in view mode? Reading view, not saving. Okay, so it is minimize this. I'm going to search for a particular patient. I wanted to look at the patient journey in hospital. Okay, so you can see probably the patient might be appearing in 2 different diagnoses. You know, he might be, it's possible. So let us look at that particular patient. April Hall. Okay, there you go. I think, you know, you can clearly see I'm able to get to that particular patient journey in the hospital. So you can see the name, gender, diagnosis and the age of the patient, and you can see they last admitted in January 20, and then within a couple of days they got discharged after diagnosed with oncology, and the length of the stay is correctly calculated as 2 days, and you can see the patient got readmitted. So you are seeing 2 different admission records. And they got readmitted by February 8th, and you can see the readmission gap is also perfectly calculated, which is close to, they got discharged on January 22nd and got readmitted on February 8th, and the readmission gap is close to 17 days in days, and the readmission flag is also shown here. So you can generate such a kind of report in case if hospital wanted to drill through a patient level journey. If I wanted to look at every patient and their admission journey and look at their admission gap, you know, they it is one of the important metric they can look at for any patient. What is the readmission gap, what is their length of stay, and then how long it took for them to return back to the hospital, the readmission gap. So that kind of analysis will help the hospital administration, I would say, to take some actions by looking at the patient level journey. So this kind of a report will really come in handy, and you can put a slicer around that and start searching with start drilling down to any patient and then generate such a kind of report. Okay, so let me probably move on. So we have bed occupancy rate and occupied beds by what key. Okay, so we have calculated bed occupancy rate and occupied beds. So you can see by ward level what is the bed occupancy rate and occupied beds. I know we have given a constant number, as I mentioned, like 10,000 kind of right, so a constant number we have given, right? So you can see the occupied beds for every ward. What are the number of beds that are occupied? So we have given a constant number, I don't remember, but it's just a cooked up data. So you can see the bed occupancy rate that we have calculated on occupied beds across wards. You know, that will give insight, you know, which ward is which ward having more number of occupied beds and the bed occupancy rate as well for that particular ward. So it clearly indicates ward A is having the highest rate, bed occupancy rate, and the beds are occupied. So which means, like, clearly tells us that particular ward handling probably complicated or chronic kind of diseases. So we can infer such information from this kind of a report. And finally, resource utilization report. So we are looking at resource utilization rate. So again, we are keeping a constant number to calculate the utilization rate by every ward, and you can see for every ward the utilization rate peaks towards the month of April, again, just for the simulation purposes, and that tells us, kind of a COVID kind of scenario, our resources are getting depleted, and probably it's nearing the breaching level, and hospital may wanted to took some action in every ward to kind of a refill, or the resource could be anything, the staff, probably the beds, or the equipments, hospital equipments, they wanted to refill. So such a kind of report at ward level provide some alarm if there are any significant peaks that you are seeing here in April month. If it's kind of outbreak kind of scenario, the resource utilization rate is higher in those months, and hospitals can take some action on that. So that's all I built in. If you think you can come up with more reports, feel free to do that and comment and provide your inputs in the comments, so that everyone will be benefited in this community. So a couple of dashboards we have here just to wrap up. So the whatever reports we generated, we are bringing in the dashboard. So this, you can say, a kind of CareOps dashboard kind of a summary that we have here, and you can see we have that total admission, discharge, and active admissions trend kind of report on top, and we have that bed occupancy rate by wards report, and average length of stay by wards. Okay, so that you can see here, and then the detailed patient journey report, which is quite critical, as I mentioned, with the slices at diagnosis and patient level, so that you can search any patient and then look at their journey in hospital, and then infer some metrics like length of stay, readmission gap, and the diagnosis information, and other information related to FactPatientAdmissions. And we have one other dashboard. So probably that you can name it as CareOps dashboard readmission kind of a dashboard, where we have the average readmission gap by dates, and we have a readmission rate % by month, and the total readmissions in every ward, and the average readmission gap in days by every ward that we just discussed briefly. We can generate just such a kind of dashboard as well. So feel free to build your dashboards and reports out of the data model that you have built, and feel free to let me know if you have any questions or any discrepancies that you are seeing, even with synthetic data that we have cooked up using Faker library. Since it's a healthcare, as I mentioned, so it's a good opportunity for us to generate some synthetic data, and we also validated with some deep dives, to make sure there are no overlaps in admissions, since there could be multiple admissions possible for a patient. So we validated all those, and then we generated such kind of reports and dashboards. So if you're seeing any discrepancies in the reports or dashboards, please let me know, even with synthetic data that we have generated. So I would be happy to help you further. So with this, we come to an end of the course. I hope you enjoyed the course, and feel free to ask any questions, or in the next module we've opened the discussion space, so that you can let me know or let community know how we can improve this solution or POC further, so that it will benefit larger community, right? So thank you very much for watching, and be a part of this course, and enjoy learning. Thank you so much.